Hello, everyone. We're going to restart our conference, so please, if you can make your way back into the hall. Next session, we have a technical presentation on by Mr. George Berberi, CEO of DC Pro Engineering. George holds a Bachelor of Mechanical Engineering from the American University of Beirut, 1985. He is a recipient of AUB Distinguished Alumni Award for Mechanical Engineering for the year 2007-2008. Founder and CEO of DC Pro Engineering, which is an electromechanical consultancy firm specializing in renewable energy master planning and integration, district energy services, data centers, and green buildings MEP design. George has 35 years extensive MEP experience in the Middle East, where he played a major role in pioneering the district cooling industry in the Middle East in 1995 and contributed for new developments in the Middle East HVAC industry and the energy optimization. George has several publications, including the Energy Budget book and several papers in ASHRAE Journal, MEP and Climate Control magazine, has chaired and moderated over 40 district cooling, data center, green building and sustainability conferences, and presented 85 public presentations in the GCC region, Asia Pacific, Singapore and Malaysia, and the USA. Please join me in welcoming George to the stage.
Actually, I use the time to go outside and drag them in. They need a stick. So I hope they'll start entering. And okay. This is important because let's talk about the CO2. You know, research said that at 950 ppm, our cognitive brain responses drop by 15%. At 1400 ppm CO2, we drop by 50%. That's why most of us are sleepy. And when CO2 go above that. Now, there is a gentleman who had a sensor in his back. I asked him to put it here. I'm glad we are fresh in this room. So we got the CO2 in this room at about 600 ppm, which is exceptional. The temperature is 21.5, and the relative humidity is 50%. So don't you feel fresh in this room? A bit cold? And it's an impressive building. I mean, if System Air has ventilated it the way, they have done a good job. And at least this is what measurement does, give us the knowledge of that. Now, a strong movement is starting to capturing CO2 from indoor atmosphere rather than just diluting by fresh air. And I see that trend will increase in the future. I mean, I see ready-made units now and more system coming up online to do that. I came to this country in 1990. We were barely 330 ppm on CO2. Right now we are exceeding 420. And the rate of increase is continuing at almost at least 2 ppm every year. So by the time you reach my age, for the young people, you will see probably 500 ppm in terms of carbon dioxide. I see still the numbers are accelerating. I don't see decline before 2030 probably. So we will peak by that time hopefully, and the rate may start to slow down. And there are also other rising contaminants. In particular in the Gulf, it is fine dust and sand, which rarely talking about in Europe, and we suffer a lot from it here in terms of sensitivity to that, and people coughing and some crystallization happening in the lungs due to a lot of sand and dust in that area. And Our doctor mentioned she doesn't have experience with high humidity. It's always in the US, unfortunately, they suffer from low humidity, especially in the heating season. Here we suffer from consistent high humidity year round. We are the world's highest humid weather on Earth, with wet bulb design temperature 30 to 31 degrees C, never heard of except in the Gulf. Even Florida design wet bulb is 27.
Humidity is 19% right.
Ah, 19. That's Bixie trying to be smart. Okay. So here I will take an example of probably Cleveland Clinic Hospital in Abu Dhabi. It was designed by the world leading hospital designer, HDR, helped by Jacobs and AECOM, and built by the world's best companies, B6. And they opted in the most humid city in the world and in the location on the island to have 100% fresh air cooling the hospital. And they thought that was good. And they did sensible heat recovery. And the hospital cost $1.6 billion for 400 rooms, or $4 million a patient room. A 5-star hotel costs $1.5 million. And what is the results? The design is 10 square meter per ton compared to what we normally design, 30 square meter per ton. The actual performance was 12 square meter per ton. The actual consumption exceeded 600 kilowatt hour per square meter per year. And the relative humidity was 70 to 80% all year. And they have to pay after that. Till now, I heard they reach 100 million dirham or $25 million just to fix relative humidity. So is it in such a humid atmosphere, can we increase fresh air irrespectively, like everyone trying to 100 cubic meter an hour per person? Is it good? I found in my career, my biggest challenge is to control humidity, and to find it here today, 50% is kind of refreshing, because this is very difficult to achieve at 21.5. Normally it should be around 60, 65% there. And of course, I mean, when you have dry air in the US, in the hospitals, they find a big spread of bacteria. But here, I was the first to tackle the mildew and fungus in sick buildings, where we had major growth in buildings. So I introduced the runaround coil in '93 that solves that problem. Then introduced the double heat recovery fresh air, and both published papers, and they became the industry standards. And we solved the issue of humidity. Right now, it's bearable, 60, 65% instead of 75, 80, but we still suffer from very high humidity in general in the area. And energy conservation. Unfortunately, most facility manager in Dubai I talked to, they shut down the fresh air. And they don't see that this is relative. They say it spends a lot of energy. Fresh air used to spend 30% to 35% of the cooling. When we introduce double heat recovery, and if we design it well, we can drop it down to 10% of the cooling energy. Again, there is lack of lot of measurement in that. We saw a lot of LEED standard and rebuilding standard calling for 30%, also Istidama and Abu Dhabi, above ASHRAE standard. I question why. And is that helping? If it is increasing relative humidity, increasing energy consumption, is it really lowering, if we meet ASHRAE standard today as is, the ppm, the CO2 vary between 700 to 3,000. Even if we increase it by 30%, the dilution, we might get 600 to 2,500. So it's not reaching the right point. Shouldn't these monitors, we monitor the indoor CO2, is it part of our design? We put constant flow fresh air in most residential and office building without any demand control, without any measurement. So if we don't have accurate, like the gentleman told me, he's measuring CO2, temperature, humidity, an item costs 500, 600 US dollar, maybe $1,000. Why we don't see them in building? Why don't we see BTU meters on every chiller? Now, right now it's by code required. Why don't we have other IEQ measurement? Then why shouldn't we all have demand ventilation in every residential and office building? Especially now in COVID, most of our office buildings are empty. What my office used to have 55 people, now I barely see 5-6 people in my office. I mean, does that call to the same standard of cooling? What about capturing CO2 and other contaminant indoor? If the outdoor keep increasing in terms of contaminant and CO2 content, and its ability to dilute our indoor air is depleting day by day. I'm not saying eliminating it, but shouldn't we at least complement it? Like I saw this in it's solar air, it's in the Finnish pavilion, maybe close by, and it cost 5,000 euro as a startup. I'm not trying to make advertising, but I'm saying that these units are become to be available standalone. They capture CO2, but unfortunately this unit release it at night because they cannot store it or transfer it. They have a unit that can mix it with some carbon, with some hydrogen, and transfer it to CH4 or methane gas, which is not, I don't see it useful. We should have CAM-FIL. I know that they used to capture CO2 using adsorbents that need replacement every time. But I believe we are in early stages of technology that are evolving to give us solution and encourage manufacturers to do so. And we need to start using them more. So besides CO2, we have CO, ozone, SO2, and O2, lead, and particulate matter, and here more dust, which falls under particulate matter as well. So if our building is located on a highway or in an industrial zone, do we treat it like here in Expo, where probably why the CO2 is low? Because this is a sustainable project, no cars, no movement. We are middle of the desert, away from highways. Probably that's helping this area to have a proper ventilation here. It's not a bad idea to increase ventilation rate in this area. But if I'm on Sheikh Zayed Road highway, it makes a difference. I mean, I need to, if I ventilate using that source, I need to worry about the contaminant coming from, or if I'm in Dubai industrial zone, Dubai investment park, or next to power JBR, next to the power generation stations. All these matters. I mean, nobody, when we design these buildings as mechanical, we don't go to the site and measure what is the ambient contaminant before we design. We don't do that. First, we are not paid to do that, and our design becoming to cut down on design, we are doing repetitive design. This is the fastest way to deliver a project without thinking. You know, in ASHRAE Standard 62, 20, 30 years ago, they removed the 1,000 ppm target. And now what they give us a variance of range. And what I would say today, if at 950 we lose 15%, that's a bit high. We should be at 800 ppm. And how can we do that with a 420 ppm outdoor air? How much more air we need to add? And this is a challenge when we start really measuring. The 7.5 liter per second deliver anywhere, depending on concentration, between 700 to 3,000 ppm, as I said earlier. We introduced this unit probably in 1999 in the area, became the industry standard here, and it helped reduce the fresh air impact in terms of energy. So the energy consumed is anywhere between 40 BTU per hour per CFM here up to 100, 110. Or if any one of you bought an apartment in London, you know that because of heritage, you cannot put an outdoor compressor. So most houses in London does not have air conditioning. And I have a rich friend. He told me, George, you are an authority in air conditioning. Can't you find me a solution? So I had to research and break my head for a month, and I saw a unit that doesn't need an outdoor compressor. It's 70 by 70 centimeter by 2 meter high. It needs 2 connections on ventilation, so it deals with 100% fresh air. It puts the heat recovery, then puts the evaporator and condenser in the same airstream, and add hot water. So the same unit that is 1 ton capacity do cooling, heating, hot water, and ventilation. What is the price tag? 10,000 pounds. The Chinese are doing 1 ton unit for $300. This is a European innovation. And I told this to some of my manufacturing friends. They told me this is an opportunity to make money. But it is nice to see such unit and such innovation coming into the marketplace. And they claim, they did a passive house actually in London like that. It covered a 100 square meter house, just with this unit to produce all 4. And that house actually consumed barely 40 kilowatt hour per square meter per year. And it's a positive, net positive house. I hope it look ugly. This is what they didn't focus on architecture, but it is possible to improve the way it looked by architecture. And that's it. It's quick for me. Hopefully, I respected time. Thank you. If you have any question, ask it. Better leave me alone. Let me go down. Troublemaker. Raise your voice, it's okay.
Okay. You mentioned a very important point about fine dust or fine sand in this region that's specific to this region. You mentioned about ventilation and the things that you take care of for like CO2 and humidity. But specific to this region, fine sand, which personally affect me in terms of health as a health issue, what would you say are the best practices to take care of ventilating a clean air that doesn't have fine sand? Because in this region, as you know, we're constantly having to dust the house. In Europe or US, they're worried about more organic dust or dead skin. But in this region, this is one of the biggest issues. What are the best practices to resolve that?
Let me talk about a hospital. Now, you know that I built this zero energy villa to prove that radiant cooling work. So the good thing in radiant cooling, it separates the sensible cooling from dehumidification and from ventilation. So that reduced cost already by 60%. And as per actually code, you need two air changes for patient room. Then you put your expensive air handling unit with, and you know, in Dubai municipality refused to put heat recovery wheel. And I invented something. I said, I saw a Falcon hospital in Al Ain done by late Sheikh Zayed. He was worried that Falcon capture virus, he put an incinerator using LPG gas on the exhaust stream. So I took that and said, why don't I put an HEPA filter on the entire exhaust of the hospital? First, to protect the technicians, like I did in district cooling. I was worried about Legionella in cooling tower. First, the concern was our technicians. Then the visitors and the patient in the hospital. Then it allowed me to put heat recovery wheel with very low cross-contamination and HEPA filter downstream. And I saved energy and, okay, we have back filter, HEPA filter, all that. They told me Dubai municipality will never approve it. They never approved it before. I sent my best engineer to present it, and they approved it. I said, nobody before somebody presented that way. It's challenging the status quo. You need courage. Now, my daughter, she's very poor in mathematics. She hates engineering. She's studying interior designer. And she was coughing in her small, in Chelsea, London. They give you 12 square meter room. And she was coughing all the time. So without even asking me, she went and bought a filter with static, and her solution was solved. It helped her. So we have the means today using proper ventilation, but I'm worried about an office building, and I'm worried about the CO2 level, especially in office building and in high concentration there. Probably we can deal with dust and contaminant. Still, CO2 is our biggest challenge. I measure it in my office. I was in big office alone, 800 ppm. So you will be amazed when you start measuring that.
Thank you, George. I think this is a very informative presentation. We always learn from your experience. My question, or a comment actually, and a question, ASHRAE just recently in February, they have released a position document on CO2. And they have mentioned different levels of CO2. One of the documents, I just was reading this yesterday, that OSHA is allowing like 5,000 parts per million for indoor level without having any health effect on a human being. Why is 800 or 1,000 you think is such a dangerous level or not a healthy level of environment? Plus the fact that there's independent studies, for example, for the submarines where the submarines dives month at a time, where the CO2 level reaches 8,000 parts per million. And there has been independent studies that there is no health effect on these seamen in the submarine. Why 1,000 is such an important...
As I mentioned, there is a research done in the state. Actually, 2 studies shows that you lose 50% of your brain cognitive reaction at 1,400 ppm. And at 915, you lose 15%. So if you notice, yes, it will not have maybe drastic health effect, and you are right. But you feel sleepy and you feel dizzy when CO2 level goes above 1,000 ppm. This is what Hassan can answer that also from ASHRAE perspective. Speak out, we can hear you.
Yes, so this statement on the CO2. I think that during, 1989, if I'm not mistaken, the standard, they mentioned this value of 1,000,
Yeah,
and
and
then
it was
people
removed.
started like quoting it. The idea was here is that if you provide the required liter per second that was in the standard, in an office building, you'd expect to see 700 ppm above the outdoor rate. But they never, let's say, said, just look at CO2 levels. The current, let's say, position document is saying, okay, there are studies, like George is saying, that shows that cognitive abilities have degraded at higher CO2 levels. But there are other studies that show that it's okay. So what Asher is saying could be a problem. Maybe it is a problem, but we need more studies to confirm that really CO2 is the driver and there was not another pollutant that was actually driving that. Because these studies, and probably Dr. Taylor can add to that, have shown, and like we're mainly focusing on CO2, but might not have captured all the other contaminants. And there might be another contaminant that was driving, let's say, these, lowering cognitive ability. So it is still not concluded, let's say, at least from ASHRAE's point of view. But in general, when you see high CO2 levels, that means it's a lower ventilation. So probably there are other contaminants happening. So it is a good idea to lower the CO2 levels by introducing outside air. That definitely has lower contaminants than the indoor air. But like capturing CO2 on its own, does that help? We'll have to see.
But Anna can ask, I'll do field research now. We are probably 60 people in that room. Anyone feel sleepy? And this is the first conference that I don't feel sleepy in. And trust me, because of the low CO2 level. Don't believe research. Trust your body, trust your nose. If you do, and Dr. Taylor, please go.
I think we have to believe research.
True. What does it say?
But I also agree that CO2 can be a marker for other contaminants as well. And I was just asking Dr. Arith, who's an anesthesiologist, what is the CO2 level in expired air? And it's quite high. So I think we do have to be careful in setting CO2 limits for demand ventilation because of the possibility that there are other contaminants. But Joe Allen's work has shown that CO2 is associated with fatigue. But I think we need to continue to research what other contaminants CO2 could be associated with.
I believe in research, and this is a field research. Every conference, I shared 100 conferences. I will tell you, I always see 2-3 people sleeping. But I see you laughing alive and kicking, all of you, and this is good, really. And trust your body. This is research. This is field research. When we do, how alive we are, that's part of the study. How do you do research on cognitive study? How do you research that? How do you associate CO2? It's very hard.
Well, I think you have to monitor multiple variables and then hopefully monitor the human being from a number of different perspectives. So both like electrical brain activity, heart rate variability, stress, cortisol levels, and saliva. And
what about alertness?
True, and alertness too. So, and actually there was a very good study that the GSA did in the United States that was published in Indoor Air in 2020, in January. Brian Gilligan was one of the authors. And actually, once again, it was found that low relative humidity was associated with fatigue. I don't know what the CO2 levels were in the government offices, but I think we have to not make assumptions about what is going to be the result of the study, but really follow the data so that we discover new associations.
I agree in that. I agree. I don't disagree totally, but I'm saying there is a lot of evidence showing as we go above 1,000 ppm, fatigue in classrooms in universities are increasing. And this is becoming like when people question the global warming, and now there are less of that. So I see there is more consensus associating high level of CO2 with fatigue now, not with other health issues. And I take this room as an example to thank you for the gentleman from put the monitor there. You can see the level of CO2. I hope it's accurate. It didn't give us false data. And Yeah, it is there. I mean, I started, recognize my feelings and I have an observant eye, and I start trusting my hunch on things, because especially when research are confusing and you have different message, not clear message, one pushing that direction and others there. This is a clear evidence for you, gentlemen. Thank you.
Thank you.
Thank you very much for an engaging discussion, George. Help me re-welcome Tobias Zimmer back to stage. Tobias will be talking about the new World Health Organization air quality guidelines and their impact on air filtration requirements for general ventilation.
Yep, thank you. So let me start where the last speaker, George Burberry, stopped. Looking at the air quality in here. I agree, we have seen there's great CO2 levels, there's great humidity, but there's also great particle levels. If you walk outside in the next break, you will see, if you go through that door right to the left in the room where the coffee is served, you will see also an indoor air quality monitor, monitoring PM 2.5 concentrations outside and inside that building. So all in all, I must say congratulations to System Air again for setting up this great system here with a lot of fresh air. So we're not talking about recirculation here, we're talking about a big content of fresh air and energy recovery. And yeah, last thing to mention, obviously the filters in that system are from Camphor. Good. So let's start. So let's talk clean air. So which means in my case, obviously we're talking particulate matter and particle filtration. So my topic today, WHO air quality guidelines, and what is actually the impact on air filtration. Because we have on the one side, we have all the guidelines giving global guidance what should be, but it sometimes ends up in not being implemented. We've heard that a bit in the last speech. So let's try to get a complete loop from what we should, how it should be, ending up with what we should do. So what is the new WHO air quality guidelines? There have been WHO air quality guidelines since a long time. The last edition was actually from 2005, so 16 years or 17 years already ago now. And it has been updated in September 2021, so 16 years after the last edition. It was about time, I would say. Because science moved a bit in the last 16 years, yeah? And what's the big thing here? What does this guideline do? It actually gives you quantitative health-based recommendations for air quality. So really based on scientific results, what concentration would be beneficial or from what concentration it wouldn't be beneficial for the human health. So if we just look at the executive summary, we can see air pollution is not a side thing, a small thing to think about. It is recognized as the single biggest environmental threat to health. So it's equally dangerous as an unhealthy diet or tobacco smoke. So we're not talking about a minor thing, we're talking about a big impact on human health. And the key question here, of course, we're talking about indoor environmental quality. Are these WHO guidelines actually applicable, or are we just talking ambient air here? Here, the WHO is absolutely clear. The present guidelines are applicable to both outdoor and indoor environments, which is quite logical, because if we look here in Dubai, how much of your time do you spend indoors? I would say more than 90% regarding the temperature. So obviously, indoor environment is probably more important than what we have outdoors. So let's get technical. There's a lot of engineers here, so we need some numbers. So what is actually written in that guideline? So what you have is limit values, annual average limit values. And let's focus on the first ones, PM 2.5, particulate matter 2.5 micrometers or smaller. And we can see that versus the last guidelines from 2005, the limits have been cut by 50% based on scientific results. nothing else. So we know that this is a critical limit. And we heard before, it's only PM 2.5. Why don't we look at smaller particles? I would agree, we should. And be sure, during the course of the presentation, we will come to smaller particles. No concerns about that. So there's many annual mean limits given, because as rightly said earlier, it doesn't help us to have a peak value. We have to see the annual mean. What's the average concentration we have over time? So a massive reduction of the threshold from 10 micrometers down to 5. That sounds like a big change for ventilation. And yes, it is. But is it worth it? Or is it just something that's nice to have? I can show you another study that will tell you it's more than worth it. Has just been recently published from the World Bank. So we're talking money now. Not talking health, we're talking money. Published February 2022. And it's a study especially on this region, Middle East, North Africa. So urban environments here are 10 times more polluted than the WHO limits. 10 times. And we see, of course, a high death toll we're paying, 270,000 dead people per year, which is more than traffic incidents, you can read it yourself, diabetes, HIV, and hepatitis combined. So it's a serious impact. And for the ones who are not interested in health, maybe you're interested in money. The economic costs for just for Middle East, North Africa, per year, are 141 billion US dollar. That's 2 to 3% of the regional GDP. So can we actually, it's not the question, can we afford to do all this ventilation and filtration? It's much more the question, can we afford not to do it? Because it costs a fortune in both, in terms of death toll, but also really in terms of money. So here a graphic from that report, which visualizes it a bit more clearly. You see that dotted line, that's the WHO limits. That's where we should be. And here we see urban areas all around the globe, and you see no one is actually meeting it. And the orange bar in the middle, we see Middle East and North Africa really 10 times above the limit. So obviously, there's a need to do something. But how? We know outdoor air is highly polluted, and the health impact and the economic impact is high, it's huge. But now we have to get to something really tangible. How do we do that for a building? It's nice to have the idea, it should be clean, but what do we need to do? Because as for the engineers, there's a lot of questions we have to answer. How polluted is it actually? How many people are in that room? If the room is empty, it's quite simple to clean it, yeah? But now we're a lot of people. So what is the activity level? So if we're all just sitting here, we consume less air and we create less particles than if this would be a gym and we all would be moving. Big difference. So there's many parameters to look at, and what we need is actually a clear and easy to use guidance to at least improve the situation. To do a perfect solution, you probably have to look at a case-by-case scenario, but to get at least some guidance, what is the right level of air cleaning that's required? And having said that, luckily there is such a guidance. So Eurovent published the recommendation 423, it was mentioned earlier in Morten's presentation as well, which gives you a quite easy guidance on how to dimension a filtration system in a building. And the good thing is, it's really up to date. So last update was January of this year. So it already takes into account the current WHO guidelines, so the 2021 version. And it also references to ISO 16890, which is the latest standard for air filters. So it's really up to date. And it is a quite simple approach. You just look at 2 parameters. That's not too much for an engineer, I would say. Yeah? We just look at how is the outdoor air, and what level of supply air do we want to have. And just by defining those 2 parameters, you get a fairly good answer of what your minimum requirement would be. So let's look into that guideline, and I promise there will be smaller particles to come. Unlike the WHO, the Eurovent 423 talks about PM10, PM2.5, and PM1. And it's obvious that the smaller the particles are, the deeper they get into our body, and the more health issues are associated with it. This is common knowledge in the meantime. So obviously, if we're talking about health protection, we have to look at the smaller particles first. That's where the real concern is. So having said that, let's look at the first selection criteria, to be very pragmatic here. So first, we select where are we in the world? What is our outdoor air quality? And it's a very simple model, ODA1, so outdoor air 1, to ODA3, outdoor air 3. ODA1 simply means your outdoor limits are below WHO limits, so your air is clean. 2 would say it's just slightly above WHO limits. And 3 says you are more than 50% above the limits, so you have polluted outdoor air, which obviously follows in filtration requirements. Needless to say that Dubai would be ODA 3. I think the current value, if I read it correctly before today, was 65 micrograms of PM2.5, which is slightly above 5. So it's more than 50% above. I think we can agree on that. So we are in ODA 3. Now we know what's outside. We still don't know what to do inside. And then we come to the second parameter, and it really gives you some guidance. You can see it's directly copied from the guideline. And there we have supply air, sub 1 to 5, supply air quality. How good should the air quality be, depending on the application? Let's start with an example. Supply air 1, which would be the best supply air quality, is obviously needed in hospitals. Not a surprise. But what supply air quality should we have? What should we have here in this meeting room or in an office? And then we come to the next class, filter class. All rooms for permanent occupation should have a supply air quality 2 at least. Still, any building owner still has the right to ask for a supply air quality 1. That was presented earlier in Morten's presentation. If supply air 1 is specified, of course that's what you have to follow. But the minimum is a supply air 2. And if I skip the whole middle, because otherwise I will spoil my time frame completely. Just look at the bottom, what's supply air 5? This is basically just enough for garbage rooms, underground car parks, and other places that are, first of all, not meant for the permanent presence of people, and secondly, are polluted anyway. I think that makes it quite clear. And then it ends up in a simple matrix. So if we just look, let's say we have an office building in Dubai. We have an office, so we need minimum supply air 2. We are in Dubai, so we are in ODA 3. Which means if we have a 2-stage filtration system, which I would recommend, it says you need a PM150 filter. For the ones that are not familiar with the ISO 16890, it's a filter that's tested and has proven that it takes out 50% of the PM1 concentration that's gone through it. Followed by a PM160 filter, which obviously takes out 60%. Those in combination means a reduction of 80% of PM1. And an even higher reduction of PM2.5, obviously. So how would that practically look like? You would take a first filter, let's say a back filter, PM150, followed by a compact PM160. Then you have fulfilled the minimum requirement. The minimum requirement. We heard earlier we have sand topics here, of course. Would that work in Dubai? Technically, yes, but the lifetime of the first filter would be very limited. As we are here in Dubai, I've prepared a few extra filters here. For sure, you would need to put a pre-filter to take out the mass of the sand as a minimum requirement. And if we ask me what I would recommend, I would even go further. I would add first stage an initial separator. Initial, just in case you have sandstorms. Otherwise, you can immediately change your filters after the sandstorm. So you have first one for the big amounts of sand, second one for the regular amounts of sand, and then we come to the small particles that are actually a threat to human health. In that setup, you would have a good filtration solution in this place. I can say in that place, we are safe. I know the filtration. But if you look at what we have in buildings here, you will find a totally different setup in many cases. I've seen many places where we just have a filtration level of a PM 2.550 or a PM 1050 even. If you follow that matrix, PM 2.550 in Dubai, that's good enough for the garbage room. Is it really the place we want to work? Probably not, huh? So, we talked a lot about energy consumption. And of course, there is always the first thought, oh, if we increase the filtration efficiency, that will cost a fortune. No, it won't. Of course, there are limits to existing buildings. But still, you can improve the ventilation and the filtration efficiency a lot without compromising on energy costs. And even if you would, we are still talking IEQ against energy. But as mentioned earlier already, if you select an energy efficient air filter, you can actually improve the air quality and reduce the energy costs at the same time. And as it's not that easy to always select the perfect product, there is also a Eurovent rating, which is not just a rating that's given pro bono, it's something connected to a certification system, so your filters are actually regularly selected by Eurovent and tested to see if it really works. Where you can, simply by selecting an A+ class filter versus a low class, you can simply save energy costs and improve indoor air quality. Let me give you a simple example. Let's take one of these standard filters you may see here. Bought on low first cost, let's call it air filter A. PM 2.550, so okay for the garbage room or the underground parking, but not for the office. Energy class E, which is quite common if you buy a filter on first cost. Energy consumption in a standardized application, 1,900 kilowatt hours per year. So that's what I have already, and we see a quite high initial pressure drop, 170. That's what my system is able to take. So let's upgrade. Let's say we have the other air filter, C, and suddenly we have not PM 2.550, but EPM 160. So significant improvement. At the same time, we've upgraded from class E to A+. And if you look at the kilowatt hours, we cut the energy costs by more than 50%. So there's even room to upgrade more without using more energy. So it is feasible, all within technical limits, but we are far away from reaching the max that we can do. So I know I'm probably running out of time, but in a nutshell, a good air filter saves more money than it costs. So if someone saves money on an air filter, it's like stopping your watch to save time. It will not work. It's the opposite. Bringing good indoor air quality will pay off double. You actually can reduce energy costs, and of course you will increase productivity, you will increase health in the building. So you can only benefit from it. So coming to my summary slides. So we have a new WHO guideline that is really a big step in that way. After 16 years, finally WHO updated it with the latest scientific findings. And we can see now that air pollution is one of the most critical things affecting our health, everything that comes from the environmental side. So it's a big threat to human health. We have to do something. At the same time, we see it costs us a fortune. Just looking at this region here, Middle East, North Africa, 141 billion that we actually waste by not cleaning the air. If we just invest a fraction of that into a solution, it would help a lot. And the positive news, to stop with something positive, there is an easy guidance how to do it. So it's not that we have to reinvent the wheel and start from scratch. We have a complete guidance. Simply follow the guideline and you will get clean air and you're able to save energy at the same time. So that's it from my side. Thank you a lot.
Can I keep the questions for later? Thank you very much, Tobias. If you have any question, please reach out directly. We will have to move to the next presentation. Please join me in re-welcoming Mr. David Shirk. He will be addressing the HVAC system's role in improving environmental air quality in buildings of all types. He will be joining us remotely, so Surinder, can we check the connection, please? Do we have an issue with the connection to connect Mr. David? Do we take questions until then? Do we take questions until then? All right, seems like we have some technical issues, so we will move to the next presentation, then we might come back to Mr. David. Please join me in welcoming Mr. Rangel Boletovich Schumer. I'm sorry if I pronounced it wrong. As Director of Cultural Development, Rangel helps companies around the world measure and improve their organizational culture around quality, safety, and environmental sustainability. She holds a master's degree from Aarhus University and a bachelor degree from King's College, London. Welcome to stage. Please.
Hi, everyone. I actually have my own introduction, so you're going to see this twice. I won't repeat it. I think the other thing to know about me is I'm also a Formula One fanatic who's lived in 8 countries and speaks 5 languages. Okay, so what does my company do? We assess culture around the world. In particular, we look at safety, quality, as well as environmental sustainability. So we're located in Dubai, as well as the UK. What we do is based on 20 years of research and development. So we've been in the field for quite a long time, and you may recognize some of the brands that we work with around the world. So let's get right into the super exciting topic of culture. And let's begin with some definitions, because funny enough, if I tell you what is culture, probably every single one of you in this room will have your own opinions on the topic. But what we work with are the prevailing attitudes and practices that are related to safety and quality that are taught directly and indirectly to employees. So one way to think about organizational culture is that it shapes how people, first of all, think about a topic. Then it shapes how they feel. And in the end, it shapes how they act. And of course, when you work at any kind of organization, you're very interested in why do people act in any kind of given way. So culture is something that is shared between us in any kind of a group setting. It's something that is learned continuously throughout our lifespan. It's a lot more than just engagement as well. So often when I work with my clients, they always say to me, oh, well, we know our engagement. We do this engagement survey, so we understand our culture very well. But engagement really is a climate check. It tells you how somebody's feeling at any given moment, but it doesn't really tell you how people are behaving. And engagement also can vary from day to day, whereas your culture is something that's really difficult to change. And the final aspect of culture is that it's really challenging to assess it. So how do you know your organizational culture? Say you have a company of 100 employees, 50 of them maybe in manufacturing, 50 of them in HR, finance, and whatnot. Do they have a shared culture? Do you understand it? So that's what we do. We help companies understand the culture. So why is it so difficult to know your company culture? And it doesn't even matter whether you are 10 people in an organization or 100, although, of course, the more you are, the more difficult it becomes. Well, obviously, it's because culture is invisible. If I ask you, what is culture? You may think of a couple of things in your organization. You may say to me, oh, we have this great foosball table, and we all gather there after lunch and we play a game. We have a great culture. Well, okay. Well, let's look at something like sustainability or safety even. So imagine you are in a manufacturing plant and you are, as an example, an auditor. You come into this manufacturing plant and you see clean equipment, you see happy, smiling employees, and you may think to yourself, this company, it has a really good culture. Look at, all of this equipment that they have, especially around safety. This looks really new, really good. That's your artifacts. So that's the very, very tip of the iceberg. Then you may think, I am going to dig deeper. I'm going to really get into the organizational cultures here and see if anything is happening. So you're looking at what kind of a training are my employees receiving? What's management saying in meetings and briefings? What's happening when employees are having a coffee break? And again, things like sustainability, things like safety may be mentioned a lot. But what happens underneath that? So imagine you suddenly have production targets that have to be met, and you have a week to meet them. And in that 1 week, there's no more talk of safety. There's no more talk about sustainability. People are just doing what they need to do. Management is turning the blind eye to everything that's important because all they're focused on is meeting the targets. That will shape your culture so much more than anything that you say in briefings or meetings or any kind of vision board that you put out. Now, obviously, culture comes with a lot of risk. So what happens when you have a poor culture? In any organization, it increases conflict. It will increase, of course, employee stress, as well as the errors that are committed. So it doesn't even matter which sector you are in. A poor culture will prevent people from doing their job to the best of their ability, but also to the degree that the company requires them to do so. That, in turn, goes without saying, limits growth and limits the success that a company could achieve. And sometimes you may wonder, because you will have companies that are toxic and they have a toxic culture, but they are very financially successful. But the other side of the coin of that is, could they not be even more successful if that was not the culture that drove them? Finally, it reduces employee retention. And this is especially something that's very relevant for the younger generation, because now there's a lot of research that shows that people that are Generation Z, so the 20-year-olds that are coming up, they're actually willing to take a pay cut to work for a company with which values they align with and where the company has the culture that they want to work with. Now, the other side of that point, of course, is that if you have a culture that works for you, then, the sky is the limit, as they say. You will have strong quality, you will have strong safety in your organization if those behaviors and attitudes are constantly worked with. Business success obviously follows from strong cultures. You'll also be able to attract and keep talent, and as well it increases people's job satisfaction and pride. So we always say, organizational culture happens to you whether you know about it or you don't know about it. But the key is to make it work for you. So the key is to have that goal in mind. What do I want to have? What kind of a culture do I want to have? And what are my goals in the future? So how do we do that in any kind of organization? One more slide about financial impact. This is something that is always underestimated. And this is a very big research work done by Dr. Cotter, who's one of the main gurus of organizational culture right now, who did this massive study of tens of thousands of people and found that over a 10-year period, companies that manage their culture actively make 516% more in profit than companies that do not. So there really is no argument against it. Right, so how do we create a culture that works for us? Now, it probably is no surprise if I tell you that it really all comes down to leadership. Leaders play the most important part in how we shape organizational culture. And often people will say, well, but what about, the bottom-up approach? Isn't that just as important? And yes, of course it's important, but that's not what's going to create the culture that you need. As a leader, you need to show that example. How do you do that? One of the things you need to show your employees is what you pay attention to. When you pay attention to something, you're telling them this is what is important. When you are acting and living it as well, you are telling them this is important. What you measure, what you control. So what kind of discipline employees receive when they don't do something that they need to do. What kind of data you gather, how you share that data with your employees. It also plays a big role. You also need to look at who you hire and who you fire. Because of course, if you say sustainability is our #1 goal, but you do not have a single person with any credentials in sustainability in your organization, then employees are not really going to believe that it's really that important. Same goes for firing people. It's important to let people go when they cross a certain threshold of, say, negligence. Because if you don't, again, you're sending a message that it's okay to misbehave. It's okay to not pay attention to this topic that is important to us. So what we as leaders really need to do is think about how we react to critical incidents, how we allocate resources, and that we share with employees where those resources are allocated, because people make a very direct connection between where the money goes and what is important in the organization, and as well how we allocate rewards and status. So if you really want to enhance something in your organization around a given topic, think of simple ways you can reward employees that are doing something for that particular thing. It doesn't have to be a big financial gain. It just has to be a recognition, something that people understand. There we go. So this is one of my favorite quotes by Chesky, the founder of Airbnb, who said that culture is 1,000 things 1,000 times. It's living the core values when you hire, when you write an email, when you're working on a project, when you are walking in the hall. And when the company was going to be sold, one of the big pieces of advice he got was don't mess up your culture. And they didn't use the word mess up, but you can imagine the word they used. But the point is, culture is so important for any organization. Okay, so what kind of things do you have to look for in an organization when you're trying to understand your culture? So what influences your culture? So we call them the 4 Ps: the people, the process, the purpose, and the productivity. So if we look at people, it's things like empowerment. So how empowered your employees are. Do they have authority to take action if that is needed? How they are rewarded. What kind of teamwork do they have? How they are trained and communicated are also incredibly important. Especially you need to look at the frequency of your training and communications on the topics that are important to you, as well as the effectivity of it. Process, that's all about the internal mechanisms in the company. So companies have structures in place that can enable a good culture. Things like management control. How are employees disciplined? How are they spoken to? Coordination between departments, between different plants or sites, if you have those. Consistency. Consistency over time is extremely important between people, between shifts. Systems. Do people understand the systems that you have in place? Are they user-friendly? Do they know how to use them? And finally, premises. We also need to have the premises in place that allows people to do their job. Purpose is all about what the company projects to its employees about its entire purpose of the organization. So it's like vision and values. Things like strategy. So how do you make your vision happen? What are the steps? Do people know about your strategy? Do they know about your vision? And targets and metrics as well. So targets are your day-to-day goals, and metrics are the things that you measure, the frequency you do it by, and what you do with the data that you gather. Finally, is productivity. So productivity is all about how proactive an organization is in managing its culture. So it's all about external awareness, knowing what happens on the outside world, how does that influence on the company inside. Risk foresight is another really big thing. Do people know what the risks are in your organization, and do they take them seriously? Then we have innovation and change. Without innovation and change, most organizations are going to suffer. Organizational learning. Do you learn from mistakes and make sure that they're not committed again? Because otherwise it's a very expensive exercise. And finally, investment. So do you have the resources? Do your employees have the resources that they need to do their job? So all of these areas is something that leaders need to think about. So it's quite a lot. And all of it has an effect on your culture. And companies, they're never good at everything. They'll be very strong in one area, a little bit of weaker in another. So it's all about the journey of continual improvement, identifying where your weak spots are, working on them, and then utilizing your strengths to compensate for those weaknesses. So as leaders, a few things. Build a team of trusted believers. Really think about the employees in your organization. If you're working with cultural change, identify the ones that are going to follow you, the ones that are going to, really believe in what you're saying and preach that gospel to everybody else too. Be really passionate about your vision and your values. People will know if you're not authentic about them. If you really don't mean it, they'll see it. They'll see it right through you. So it's really, really important that it's something that you preach, but you also live. Another thing you need to do is support and show respect for the processes that are in place. If you expect your employees to follow the processes that you do not do yourself, it's not going to work. Because again, you're sending them a message, it's not that important. It's not important for me, I'm not doing it. It's, do as I do, not just as I say. And finally, be aware of what's happening around you and be responsive to what's happening in the world. Because people really look at leaders for that support. There's so much information going on left, right, and center that it's important we do that. So, it's all about stability and flexibility. It's all about people and profit. And those may seem as contradictory things. And sometimes they are. And therefore, it's a very careful balancing act. As leaders, we always have to think about, okay, what's stable for my organization? Where do I need to add some flexibility to it? How do I prioritize my people, but don't lose the profit? And it's not easy, but it's important. So I'll give you a very quick example on what happens when that balance shifts. So, does anybody remember the Boeing 737 MAX crisis of 2 airplanes that crashed? Yes, and 346 people were killed. A big report was published into the reasons, and actually at the end of the day, culture was to blame. Culture of concealment, quite precisely. So what really happened? Well, it was a technical failure, right? There was this thing called MCAS that was put on these engines, and they failed, and the planes crashed. Why did that happen? Well, insufficient training and communication. What turned out happened was that the pilots had no training around MCAS. They did not know that the system was put in place there to stabilize the aircraft when it was taking off. So when the aircraft started doing things that they didn't understand, they had no idea what to do. They were not trained, they were not communicated in it, they were terrified, and a couple of minutes later, both planes crashed. And why did that happen? Well, the company had a massive lack of risk foresight. Basically, what was going on inside of Boeing is that they were competing with Airbus. Airbus released a new airplane, very fuel efficient, that they built from scratch, designed from scratch. And then Boeing said to themselves, we want one too. But we're not going to start from scratch. That takes a lot of time, a lot of effort, a lot of energy. We'll just take our existing plane and we're going to modify the engines a little bit. But then they found out, that kind of destabilizes the plane. Oh, yes, we know. We'll put this MCAS thing on. But we're not going to tell anybody about it. We're not going to train anyone in it. It'll be our little secret, and I'm sure it'll be great. It'll be fine. And obviously, it wasn't. So why did that happen? Well, there was a conflict. There was a very clear conflict in the organization between the speed that they felt they had to produce the airplane in and the safety. And then safety was not the number one value. And it's really, obviously, this is a very big example. A lot of people died. Boeing are still suffering the consequences. They are embroiled in a bunch of lawsuits. They are lost billions and billions of dollars. But really, if you think about it, how much human suffering could have been avoided if this did not happen? And while this is extreme for Boeing, but this kind of thinking process applies to so many organizations, regardless of what you produce. So at the end of the day, culture, it's more than just a statement. You can't say how we act. We lead on safety, quality, and integrity. And our mission and vision is in everything we do and in all aspects of our business, we will make safety a top priority. In hindsight, Boeing's motto here feels quite cynical, doesn't it? Right. So another final slide to think about in terms of leadership. So when you have a company, that organization is always set things like requirements. They have to fulfill certain requirements. They have to fulfill certain standards. There are metrics that are put in place. There are targets that they have to meet. There are vision and values. These all put pressure on an organization. It puts pressure on a company. And that pressure, if you're saying to an organization, you have to meet all of those things, but you don't support the organization, you don't support the company, and there's a lack of resources, and there's conflicting priorities, and there are other barriers, then those goals cannot be met. So, thank you very much, and I hope I inspired you to think about your culture.
Thank you very much. I think we've solved our technical issues, and we have David back. David, we're ready for your presentation. We cannot hear you, David.
Now you can.
Yes, we can.
I hope.
Yes.
And you can see my screen, I hope.
Yes, we can.
Thank you so much. Well, first of all, I'll say it's an absolute honor to be here in front of this worldwide audience this morning. I would be thrilled if I could be there with you in person. Unfortunately, I cannot, perhaps next year, but regardless, it is a large audience, global attendance, and I look forward to the conversation that will follow. I am going to be talking about the HVAC, and that, of course, is heating, ventilating, and air conditioning systems' role in improving environmental air quality in buildings of all types. And I will start by saying that the conversation is going to revolve around what I call balancing the HVAC system approach to create an HVAC system that contributes to indoor social distancing. Now, let me explain what I mean by that briefly. You know, in the past, at least here in the United States, when we would walk up to a building, either during the pandemic or where we are right now, we might be stopped at the front door and we might be asked, how do you feel? Have you been around anyone ill? Have you been sick lately? And we may get our temperature scanned, and if we pass that gauntlet, we might be allowed inside the building. And up until most recently, we were being asked to wear a good, tight-fitting mask indoors and to maintain artificial social distancing, one person from the other, in case someone might have be infected with SARS-CoV-2, for example, that could be transmitted to someone that is hopefully healthy in the building. And then someone would come around behind us typically and clean up surfaces, not necessarily once a day, but maybe once an hour or maybe even more often. And of course, since the vaccines have taken effect and have been shown to be pretty effective, a lot of that has gone by the wayside. But we know that in indoor environments, there are a lot of other things in the air that we should try to distance ourselves from a standpoint of the contaminants that are there and the possibility of us breathing them. And you're hearing a lot of that information being parlayed to you today. Now, I'm going to talk about the cornerstones of a good HVAC system, and I'll start in the upper left-hand corner of this slide with ventilation. And what I mean by ventilation is the amount of hopefully clean, fresh outdoor air that we bring into the building to help dilute the specific contaminants of concern indoors, as well the number of air exchanges that I provide to the space to help flush those contaminants from the indoor environment. Lower left-hand corner, of course, air filtration. You've heard a lot about that. The efficiency. Here in the United States, we look at MERV ratings, our MERV efficiencies of filters, and we attempt to select the filter based on the specific contaminants indoors and their size so that the filtration can be efficient at extracting those contaminants from the air. Upper right-hand corner, relative humidity. We've heard a lot about that 40 to 60% relative humidity sweet spot indoors that seems to be the most beneficial for human beings from a physiological perspective as well. It may have certain limiting influences on viruses and other pathogens, perhaps limiting their viability, perhaps the longevity that they can remain infective in the air. So those I consider ventilation, filtration, and relative humidity to be cornerstones of balanced HVAC systems. And then, lower right-hand corner, we may want to consider advanced indoor air quality technologies. I'm talking things other than ventilation, filtration, or humidification that can be added to the HVAC system that will make any of the individual methodologies I just spoke about more effective, or perhaps bundling them and making the entire HVAC system more effective as well. Now, I'm going to be talking specifically about needlepoint bipolar ionization moving forward because we just don't have enough time to talk about all the options that are available. I'm typically talking about electronic air cleaning technologies. The reason that I picked needlepoint bipolar ionization is, of course, I work for a manufacturer, in full disclosure. I have 14 years of experience applying this technology in critical care environments as well. I just recently wrote an article that appeared in the ASHRAE journal. The ASHRAE is the American Society for Heating, Refrigeration, and Air Conditioning Engineers. And that peer-reviewed article in the November 2021 issue has garnered a tremendous amount of interest in the topic, so I think it's very timely as well. This slide, I think, tees up the conversation perfectly. Moving forward, you see a young lady sitting in a room. She's holding her hand up in a sunbeam of light that's coming in through the window, and in that sunbeam is being illuminated all kinds of stuff. We know what that stuff is. That stuff, of course, are particles. We know as well that everything in the air at the end of the day, is a particle. Most certainly viruses such as SARS-CoV-2 and others, bacteria, smoke, fungi, VOCs, products of combustion, all kinds of things are particles in the air that we're breathing. But she most certainly is concerned because, number one, she's never seen it before. She didn't realize she was breathing all that stuff. And number two, she knows she spends 90% of her time indoors and she breathes a lot of air. In fact, we breathe somewhere in the vicinity of 400 cubic feet of air every day. So she's rather concerned with what she's seeing. But what she's seeing is just the tip of the iceberg, unfortunately. The vast majority of the particles in the air that we are breathing, and a typical cubic foot of air in an indoor environment such as the one she's in, your home, your office, your school, perhaps even hospitals or the room you're sitting in right now, can easily contain 18 to 20 million particles per cubic foot. So it most certainly is a concern. The issue is simply that the vast majority of those particles, some 95%, are smaller than what you can see even when you illuminate them in a beam of sunlight, and they are smaller than what you can count when you walk into that environment with your traditional handheld particle counter that begins counting particles at about 0.3 micrometers, considerably smaller than the 2.5 micrometer particle size we've heard a lot about today. These are very, very, very small microscopic particles that can be a tremendous issue of concern in the air that we breathe for various reasons. One of those reasons is simply that they are very difficult to transport from the indoor environment in which we may be occupying and breathing back to the HVAC system where perhaps technologies have been installed and placed in order to remediate those issues of concern. In fact, science is giving us a lot of information of late with regards to just how difficult that is. And on March 23rd, 2021, the Centers for Disease Control and Prevention updated their COVID-19 ventilation in buildings frequently asked questions, and that question simply was, can COVID-19 be transmitted through HVAC ventilation systems? And they said the risk of spreading SARS-CoV-2, the virus that causes COVID-19, through ventilation systems is not necessarily clear at this time, but while airflows within a particular space may help spread disease among people in that space, there's no definitive evidence to date that viable virus has been transmitted through an HVAC system to result in disease transmission to people in other spaces served by the same system. The issues of concern with regards to SARS-CoV-2 and perhaps other very, very, very small airborne contaminants appears to be originating in the space, they're being emitted in the space, and it appears they may be remaining in the space indefinitely as an issue of concern there. Now, the good news, if there is any, is that if you and I are in a space together in a larger building that's served by a central HVAC system, if I'm ill and I talk or cough or sneeze or breathe into the air and you're in close enough vicinity, regardless of the distance, you may be infected. That's not good news, but the good news is others throughout the building may not if it's not being transmitted through the HVAC system. But most certainly, if we are in spaces with someone that may have a disease of some type, such as SARS-CoV-2, we want to be protected in that space.
David, we lost your voice. We lost your voice for the past 30 seconds or so.
I was out of my back.
Now you're back, yes.
Did you hear this slide?
No.
I don't know what's going on.
Not all of it, though.
Okay, I'll cover it real quickly. Centers for Disease and Control and Prevention updated their ventilation facts on March 23rd of 2021. That question, or that frequently asked question, was simply, can COVID-19 be transmitted through HVAC ventilation systems? They said that basically while airflows within a particular space may help spread disease among people in that space, there is no definitive evidence to date that viable virus has been transmitted through an HVAC system to result in disease transmission to people in other spaces served by the same system. Now, I mentioned, if you didn't hear it, I don't think you did, that there's good news and bad news with regards to that message. Here's the situation. If you and I are in a space together and one of us is ill and the other is not, and you are talking or coughing or sneezing or breathing or singing into the air in which we are both sharing, there is a possibility that if I am the one that is healthy and you are not, I may become infected with some type of an airborne transmitted pathogen of some type. Could be SARS-CoV-2. The good news is simply that if that space is within a larger building that is served by a central HVAC system, we may not see that risk of concern being transmitted to other spaces within the building itself. What we are being told of late is simply that the issues of concern, specifically with SARS-CoV-2, seem to be originating and they are being emitted in this indoor space environment, and that if we want to be effective at treating them, we need to treat the space. If that's where they are originated and that's where they remain, it makes sense that we need to treat them in that specific location to have a profound benefit. Now, if we're going to treat the issues of concern in the space with some type of an advanced indoor air quality technology, an electronic air cleaning technology of some type, not only needlepoint bipolar ionization, but perhaps bipolar ionization or dry hydrogen peroxide or UVC lights or electronic or polarized air filtration or other types of technologies that are out there, we need to make sure that we apply a technology that has been validated for zero ozone production. Underwriters Laboratories here in the United States will provide a manufacturer with testing and a seal of validation with regards to their product's inability to produce ozone. We know that ozone is a toxic gas. It's a respiratory irritant. It's not something that we want to be producing indoors in environments that we're trying to make healthier. So regardless of the electronic air cleaning technology that you apply, please make sure that it has been validated to those standards, and you can certainly jump onto Underwriters Laboratories website and validate any particular manufacturer's product for its ability or inability to make ozone. Let's talk a little bit about what an ion is, since we're talking about ionization. An ion is simply an atom or molecule in the air that has been imparted with an energy potential, an electrical potential. It is either positively or negatively energized or ionized. There are no neutrals. Neutrals can't do work. Positive and negative ionization, because it has an energy potential, can interact with certain pollutants in the air and do away with certain issues of concern, help remediate or mitigate certain risks. I will most certainly talk about that moving forward. Now, while you cannot see an ion, you cannot smell an ion, you cannot feel an ion, you cannot hear an ion, you most certainly can count them. There are ion counters available that will count both positive and negative, therefore bipolar ionization. And where ionization is created outdoors is in naturally occurring phenomena such as lightning strikes and waterfalls and plants and things of that nature. And where ionization is imparted to the air outdoors is typically where the ion concentrations are the highest and where the air is the cleanest. They have the ability to impact certain pollutants in the air. In part, that's why nature creates them. What happens is that where the air is the cleanest and the ions have been imparted in highest concentrations, that air moves inland. And as it moves into more polluted urban environments, such as downtown somewhere, where we have created a tremendous amount of pollutants outdoors, those ions are depleted as they work to help remediate those issues of concern. And I'll talk about what some of those might be moving forward, I promise. But the problem then simply is when we come indoors, where the air is even dirtier, for lack of a better term, where the air is less clean. In fact, the EPA will tell us the indoor environment is sometimes 5 to 10 times more polluted than the outdoor environment immediately encapsulating the building. We see ion concentrations degraded even further, orders of magnitude less than what they are in the outdoor air where they have been imparted by nature. What we do with needlepoint bipolar ionization or any ionization technology is simply impart an artificial charge of ionization, of electrical potential, both positive and negative, to the atoms and molecules that flow over the device, that go out through the HVAC system ductwork and leave the registers and grills, circulate in the space with air motion, and interact with the pollutants and contaminants of concern in the space. It is that simple. One of the most profound benefits of ionization is what I will call agglomeration by attraction. Now, we're talking positive and negative energy potentials in the atoms and molecules in the air that's been delivered to the space. For a minute, think of a magnet. We know that magnets have polarities. They are either positively or negatively polarized. And we know that when we bring opposite magnet polarities in close proximity to one another, what do? They are attracted to one another. They clink together. Two smaller magnets are attracted, they're polarized, they're brought together, and they're made larger. The same thing happens with the positive and negative ions in the air that is delivered to the space in the air that we are breathing. As the positive and negative ionization either charges and or mixes with oppositely charged particles in the space, through electrostatic attraction, they are agglomerated. Clink, clink, clink. They come together. Positive to negative, negative to positive. And the very small particles that I talked about in the sunbeam that are too small to see and too small to count, but most certainly are there and most certainly are of the greatest concern to us because they're the viruses and pathogens that can do great damage to us as human beings. They are made larger over time. They are agglomerated, they are made larger, and because they are larger, it is easier now to transport them through more traditional air movement in more traditional environments served by commercial HVAC systems. This is basically clean room technology. We've used it for decades in clean rooms to make them really, really, really clean. In a clean room, you're not going to have 18 to 20 million particles per cubic foot. You may have 10 or less, depending on the ISO rating of the clean room. In clean rooms, we have tremendous air velocities and air motion. We have very high levels of filtration, sometimes ULPA filtration, which is 99.99997% efficient. And then, many times, you will add bipolar ionization to the air to allow the electrostatic agglomeration of the very small particles so that we can make them bigger quicker and influence their movement more easily out of the space back to the HVAC system so that the components installed there to help remove them from the air, perhaps filters and other things, can be more effective. It's simply like a sailboat. We know that if a sailboat is sitting in the middle of the ocean and the mast is up, the sail is down, a gale force wind can come along and it's not going to propel that sailboat. It may just sit there and rock. But the minute I open the sail and expose more surface area to the air that's coming in contact with it, a very gentle breeze can come along and quite efficiently and effectively convey that sailboat or push that sailboat across the water. All we are doing with needlepoint bipolar ionization through electrostatic attraction and agglomeration is opening the sail on the particles, exposing more surface area to lower velocities of air so that lower velocity of air can be more effective at moving them out of the space. And because they're larger, filters most certainly can be more efficient as well. But that is not all that needlepoint bipolar ionization can provide as far as a benefit goes. We most certainly have tested this technology, and because we have imparted an energy potential to the atoms and molecules in the air, they can do other things, such as interact with viruses and pathogens. And this technology has been conclusively tested under third-party laboratory conditions to have the capability of inactivating certain viruses such as SARS-CoV-2, such as the Delta variant, norovirus, human coronavirus strain 299E, the first one, Legionella, C. diff, tuberculosis, MRSA, and others that anyone in the healthcare arena will probably recognize quite rapidly. It has the capability of interacting with the surface proteins of the viruses and pathogens that may be being transmitted within the indoor air and helping to inactivate or render them incapable of infectivity.
And vi har att säga att han brukar säga.
David, we lost you again, David. Just the slide.
Okay, are we good?
Yes.
I'm sorry, I don't know what's going on. My mic keeps going on and off. So this is a simple example of how needlepoint bipolar ionization might be mounted in an HVAC system, and from there how it can actually treat the space. You will notice an HVAC system on the right-hand side, including ductwork and filters. It probably has a heating and cooling coil, hopefully a humidifier of some type. You'll see needlepoint bipolar ionization installed in the HVAC system, and I will show you in a minute how it can reach out into the space from there and treat the space itself, which is what evidence suggests we probably should be doing. In the space on the left-hand side, of course, I have all kinds of issues of concern, perhaps, in the air that we are breathing. Now, with needlepoint bipolar ionization, I impart an energy potential, positive and negative ionization, to the atoms and molecules in the air that cross through the device, enter out through the ductwork, leave the registers and grills, and mix with mechanical ventilation in the space to come in contact with all kinds of things, perhaps viruses and pathogens, perhaps volatile organic compounds, which are odors, and of course other things in the air, including allergens and smoke, odors, dust, particulate, all of those being particles. Again, the ones in the sunbeam that are impossible to see and almost impossible to count. And through a number of mechanisms, the most profound being the agglomeration effect, I'm able to perhaps begin inactivating viruses and pathogens, perhaps breaking down or attaching to volatile organic compounds, as well agglomerating all the other stuff in the air. And because it's larger, and I can influence its movement more easily with traditional air velocities like we see in more traditional commercial HVAC systems, I'm able to convey those contaminants of concern from the space back to the HVAC system, where now it can much more effectively remove contaminants from the air. There's a big difference between filtration efficiency and filtration effectiveness. Most certainly, there are a number of highly efficient air filters that can be installed inside residential and commercial environments. The issue of concern is simply if the contaminants of concern cannot be conveyed from the space back to a filter that may be mounted at considerable distance from that space, the filter itself may not be effective. It could be 100% efficient, but if the particles don't get back to the filter to be extracted from the air, the filter will not be effective. Needlepoint bipolar ionization is simply a technology that makes ventilation, air movement, and filtration, the extraction of particles from the air, more effective. It is that simple. It is not filtration. It is not ventilation. It requires those. And then combined will make the entire HVAC system more effective at doing what it has been tasked with doing from a standpoint of creating healthier, safer, and more productive indoor environments of all types.
David, sorry to cut your train of thoughts, but we have a minute to wrap up, please.
That's it. I'll leave it at that. It's a technology that can be installed anywhere in the HVAC system, starting in the space, working back through the ductwork into the mechanical system itself. And with that, I will say thank you. And if you have time for a quick question or two, I'll be happy to take that.
Thank you very much, David. I do not think that we have time for questions, but please, if anyone would like to address any questions to David, I'm sure Climate Control can share his details. Thank you very much,
That'd
David.
be great. Thank you.
Next, we have a panel discussion, and it will be moderated by Hassan Yunus. Hassan is actually my co-founder and co-CEO at Griffin. We're a multidisciplinary firm, and we work in the new construction, existing building, serving energy efficiency, sustainability, engineering, and architecture. On a personal level, Hassan has a lot of, more than 15 years of experience consulting for high-end projects across the MENA region, encompassing MEP designs, energy efficiency, commissioning management, sustainability measurement, and verification. He was also involved in energy and sustainability advisory services and policy shaping studies for many governmental entities in the GCC. He is an internationally certified trainer with the Association of Energy Engineers, with EVO, as well as a lecturer with the ASHRAE Global Training Center, and is the facilitator of the Building Retrofit Program with the Emirates Green Building Council. He is an appointed consultant for ASHRAE 62.1 standard, and is a member of the training committee for the CMVP course. Hassan was the president of ASHRAE Falcon chapter and the vice chair of SIBSI regional chapters. He remained active on the technical committees with both organizations to shape industry change. Please help me welcome Hassan to the stage. And From this, I'll hand over to Hassan to chair the remaining of the conference. Thank you very much for joining us today.
Thank you, Omnia. So now we move into a panel discussion on IEQ, energy efficiency, and renewables. How can we combine all these three? I'm going to invite the panelists now. I think we have many panelists today with us. I'll start with Dr. Simon Miller, I think was previously introduced. I see you either got promoted or your designation got longer. You're the Government Regulatory Research and Impact Analysis Specialist with the Abu Dhabi QCC. Thanks, Simon. Next, we have Azmi Abul Huda, who is Director at Emergy. Azmi leads Emergy, a privately held corporation specialized in the built environment field with focus on enhancing and troubleshooting building performance, energy and sustainability, and energy optimization, design of special solutions in the built environment industry, commissioning process, environmental services. Azmi is also active with different societies like ASHRAE and SIPSI as well, and he has more than 20 years of experience in the built environment. Thank you, Azmi.
Thanks.
We also have with us Marcus Latner, who is the Managing Director from Eurovent. Please help me welcome him to the stage. So Marcus is the Managing Director of Eurovent Middle East, the first HVACR industry association in the region. He has been with the industry for more than 15 years in an international role and has always advocated joint industry initiatives in the fields of energy efficiency and indoor air quality. Please help me welcome Dr. Adel Houssai, who is the Research Scientist, Energy and Building Research Center of Kuwait. He's going to be joining online. Okay, so Dr. Adel has over 35 years of experience, research experience in materials corrosion science and corrosion engineering. He holds a PhD degree in corrosion engineering from Imperial College, UK, and he's been doing a lot of research with KISR, who is the Kuwait Institute for Research, Scientific Research. The research areas of interest are related to binders, pozzolanic admixture, substitution of cement and concrete, corrosion in concrete, forensic investigation of catastrophic engineering failure related to oil and water industries, in electrochemical impedance spectroscopy. I hope he is with us online. Next, we have Mr. Enrique Pereira, who is the Chief Executive Officer from TACA Solutions. Please help me welcome him to the stage. How are you doing? So Enrique is the CEO of TACA Solutions, a UAE-based technology, engineering, and finance company that delivers comprehensive energy solutions to improve energy and water efficiency, reduce carbon impact, and save money. Enrique has extensive experience in leadership roles with more than 15 years in the ESCO and energy efficiency markets across Europe and the Middle East. Prior to joining TACA Solutions, he was working with the Ras Al Khaimah Municipality Department and was responsible for the retrofit program, running the program in there. His prior experience includes leadership roles such as Vice President of the Portuguese Business Council in Dubai, Managing Director at Siabra Middle East, Managing Director at ISA, and Vice President at Critical Software and Manufacturing, among other posts throughout the years. Next, we have Dr. Rajendra Shende, who is the Chairman of TERI Policy India. He is the former director in the United Nations UNEP program. Dr. Shende has simply smart approach for addressing global challenges. That was also his seminal faith base on which he led an innovative capacity building program for all the 146 developing countries in the world that was widely acclaimed as driver for the uniquely successful global environmental treaty called the Montreal Protocol that aimed at recovering the stratospheric ozone layer, which I think we're doing at least well in that area, hopefully. So Dr. Shende was the coordinating lead author of special report of Intergovernmental Panel on Climate Change that won the Nobel Peace Prize in 2007. He is recipient of Nobel Peace Prize citation. He is a senior expert nominated by India on Technology and Economic Assessment Panel of UNEP and serves as chairman of International Advisory Panel of Operation Earth, China and Media, India, France. He won numerous awards And he was felicitated by the President of India for his work on solar vaccine cooler with natural government. Thank you for being with us. We have also on the panel Muhammad Zakaria, who is Chief Consultant at Suhaimi Design, Prot Cooling, Saudi Arabia. Is he joining online or? Okay, he's with us, yeah. So Muhammad is the Chief Consultant for Prot Cooling Division of Suhaimi Design. This division is providing engineering services for high-end HVAC systems, district cooling and other MEP projects, including system design, construction support, commissioning consultancy, and system troubleshooting. Zakaria has a lot of ASHA certifications. He's also CM certified, CMVP certified, especially in district cooling and also in build the environment in general. Thank you for joining us. We also have with us Mr. Khalid Al-Mulhim, who is the Business Development Director of Suhaimi Design. He is former engineering consultant in Saudi Aramco. I've met him many times in our ASHRAE conferences. And he has around 34 years of experience in HVAC and utilities. He's experienced in design, construction, and commissioning of MEP systems. Last but not least, yeah, I think that's it for the panel. There are too many people on the panel. So
how much time do we have?
So just for introducing people, we took 20 minutes.
Closing words.
So please, next time, try to summarize your... All right. Thanks everyone for joining us. This is an exciting panel. We've seen people talking about energy efficiency and cost of indoor air quality, and even in indoor environmental quality. For this panel, we are focusing mainly on IEQ and its cost, and how do we marry these two components, cost of energy, IEQ, through renewables, as well as one of the things that could help us drive that. So let's get right into it. I was hoping I don't use any papers. I was only planning to use my phone, but since I'm continuing after Omnia, so I have these papers with me as well. So I'll be looking at my phone, so sorry about that, and a paper sometimes. So let's start with the first question. How can we balance the cost of improving indoor air quality with the extra cost of improved IEQ, taking into account additional emissions, because that's something also we're looking at, the total cost of ownership, especially in climate, and I think we've seen with George's presentation, we have the highest probably dry bulb and wet bulb at days. At days we are, having really high dry bulb temperatures. Other days we have very high wet bulb temperatures. So I'll start with Azmi. If you can tell us on that point, how do we balance the cost of IEQ versus improving indoor air quality?
Thank you, Hassan. Can you hear me?
No. Yeah, now it's on.
Yeah. And thank you for having me today here. I'm very delighted. Regarding the balance, which you asked about, this is actually a tricky question, which I prefer not to have it in the first place. We need to think about indoor air quality as a priority, and not as something that we need to balance with energy efficiency. These are two things that need really to go in parallel. We need to deliver and to provide indoor environmental quality at the highest efficiency possible. We don't want to save energy or to consume more energy. I mean, to have this indoor environmental quality. We don't have to think in this direction. However, we have really to think about how much does it cost, whatever it costs, we need to provide this indoor environmental quality. And to make my point clear, for example, we have many researchers talking about how much does it cost to avoid the indoor environmental quality. So let's think in this direction. How much does it cost if we avoid the indoor air quality? So if we know that, for example, there are studies talking about children in the industrial countries who are allergic and who have asthma problems. And so how much does it cost really in terms of health to treat these children. So this is important factor. There are studies which talk about the increase in productivity in indoor spaces when, for example, there is a study in a call center where they have changed filters and cleaned filters periodically, and this has increased the talk time in a call center by 10%. So what is the cost of this 10%? So we need to compare apple to apple, and we need to have comparisons in a proper manner so that we are able to take a correct decision. We have studies talking about productivity in schools and performance of students in schools, which have improved by 14% when they increased or when they applied ventilation of 10 liters per second per person. And this 14%, what does it mean? It means actually reducing 1 year of schooling to children. Instead of going 12 years to the school, they can go for 11 years, for example. So what is the cost of this 1 year reduction? So let's put this cost element into the equation of avoiding the indoor environmental quality. And here we will see that it is not a matter of balance between two things that should really go in parallel, and that we don't need to find a meeting point or a balance point between. Thank you.
Thank you, Azmi. Mohammed, you're a consultant. I think you get asked by clients, okay, how do I put $1? I mean, we heard what Azmi mentioned, that, okay, let's try to put $1 to the indoor air quality. When you're designing new buildings, for example, how do you address that?
Thank you very much for having me in this conference. I'm excited to be part of this discussion. This is a very tricky balancing act we have to do here. The most important thing I think we need to bring to the fore is that we need to reorganize our priorities. We never had, for example, IEQ to be a much higher priority than anything else. If we have to think about prioritization, like, for example, the way I look at it, we do have lots of opportunities, but we need to only realign our thinking process so that we can capture these opportunities. Just to give an example, let's say there is an energy conservation opportunity which everybody uses. For example, using the opportunity of free cooling economizer cycle or something like that. But this economizer cycle process is primarily considered as an energy saving opportunity, and the focus was not IAQ. So because it was simply an energy saving opportunity, sometimes people don't pay attention to it, and they don't, might not take care of it, or the benefit was not fully realized. But if you reorganize the priority and make IAQ to be the priority and utilization of economizer option as an IAQ solution, then definitely we can do a better IAQ at least different seasons of the year, also saving energy. So that means there are opportunities which we really have to rethink so that we reprioritize and try to get benefit. So, and similarly also looking at other opportunities, like for example, we have to increase ventilation rate. We do have opportunities of energy recovery and things like that. At the same time, it's also possible that we can reduce the cooling requirement of the building by considering, for example, passive housing or passive building design opportunities, reducing thermal bridging, or whatever possibilities that we can have, so that we can extract some energy benefit there that may be available for us to utilize in the higher ventilation requirement scenarios. Similarly, also, for example, the opportunity of operating. This is not only design, because as you know, humidity control is a critical thing, particularly during summer. But humidity control during summer sometimes have a particular sequence of operation, and that operation doesn't have to be the case during winter or off season. So we need to realign the entire operating process so that we can save all the energy that we lost in summer during winter if we appropriately realign the entire operating process on the most energy efficient way based on or to maintain the indoor temperature, humidity, along with the other conditions. And again, maintenance related issues, like for example, maintaining a clean coil, for example, using UV, or maintaining clean filters, appropriate selection and proper replacement strategies. So these are all multifaceted dimensions where we can get benefit. This is what,
Thank you.
as a first step, I think about.
Thank you, Engineer Zakaria. Anyone want to add on that particular topic, or can I move to the next question? Okay, guys. That's the next question then. And this is probably, I would say, Simon, maybe you're the best to answer this question. What is the role of, and also Marcus, what is the role of entities like ESMA, Abu Dhabi QCC, Eurovent, AHRI, whether they're local or international, in assuring availability, feasibility, and efficacy of IEQ improving products? Because we hear about a lot of products, like we just heard about, let's say, a product just now. How do we know and assure that this product actually works? And what is the role of organizations you work for in doing that?
Sure. Shall I start? Someone, please. Let's see, my mic's on. Yeah, I think we really take a directed approach on this from our perspective of looking at new products and particularly new technologies, that we need to understand the risk of compliance, right? Or the risk of non-compliance, let's say, in this respect. We had a big example, I think, in the last 2 years with this advent of, as I mentioned before, UVC. Was a big product coming into the market to try and help people to combat COVID in closed spaces. What we did see though is that a lot of product and a lot of technology coming in was untested. Standards were not in place yet, and ability to be able to really understand how this even worked against the new pandemic was one of the big questions. And we saw product that was obviously trying to get into the market, which was clearly fake and not going to address this as well. So we have to do a risk assessment. When it comes to a number of other products that have been tried and tested, maybe there's a good international certification or international standards, then we can take a more of a backseat approach. We know that the market is in control, and that that from a regulatory perspective in the UAE, that that we have to take a less hands-on approach. This is, I think, something that is important for any of these questions: is what is the risk to the end user, particularly of regulation and enforcement.
I think that's a very important point. Not just if it works, but maybe it is fixing a problem, but creating another problem. Like, let's say ozone creates ozone or emits ozone. Marcus?
Yeah, I think association, in our case, we fulfill various roles in this context. First of all, we have the ability to coordinate among the industry and see if we can come up with certain recommendations which may be helpful to the governments to react on certain grounds. Then, of course, we also are a representative of the industry, so we can be a partner to the government, sit together and develop solutions, specifically when we talk about regulatory frameworks. And last but not least, of course, also the certification aspect, which is not done by us as an association within the association, which is an independent operation. But product certification, of course, provides a huge benefit to all the stakeholders, be it the end user, the government, the industry. I want to go back to what Tobias Zimmer before has mentioned, and what you were talking about balancing on the cost factor, for example. If we follow Tobias' slide before that, you said, okay, you can cut down on energy efficiency by improving, or while improving the filtration efficiency of an air filter by making use of a certified program for certified air filters. This is a very good example, I believe, of what can be done in order to bring this, or to split this cost discussion away from the energy efficiency. I totally support what you have said. We cannot have this discussion, or we should never have this discussion combined, that we talk about energy efficiency and indoor air quality fighting against each other. So role of an association in this field is I think pretty clear. We have to or we should be there to coordinate among the industry, bring the topics up, create awareness, educate the market on what's available, what is here already. I can promise you that we have the technology on the market already. You can go and use it. It's all there. It just needs to be used.
Thank you, Marcus. I do agree that different organizations do bring value. It's just that I feel that a lot of people don't know like where to get the information from. And I see like say for with Eurovan, with AirTry, there are a lot of products that are available to be checked. And instead of like doing your own research, probably others have done that research and it's available. Dr. Rajendra, I have a question for you because I know that you've worked with many governments. We've worked with yeah.
I'm not able to hear you properly. Probably when you're standing, I was able to hear you. But when you're sitting, I'm not able to hear you.
All right, so that's
sorry for that.
So is it okay now?
Yeah, sort of okay.
All right, fine. So my question here, what is the role of government entities in addressing indoor air quality and energy efficiency? I know that you've worked with many countries, your own country, and so tell us, like, from your experience on that, what do you feel the government, what should they do from your vast experience, let's say, in this topic?
First of all, thank you to Surinder for inviting me. I think you did introduce me to have worked in United Nations to save the ozone layer, which we did. And I would like to give the same principle where the governments acted to do the job the same way how they can do it here in case of IEQ. 196 countries at the time when it was realized that chlorofluorocarbons are polluting the stratosphere, what we should be doing? The simple answer was stop the production of CFC. Simplified. No complications, no filtration, no energy efficiency. Just stop the production. Job was done in a targeted time. And we are here in a bright sunlight in Dubai, that we are not getting affected by the depletion of the ozone layer now. I think the same thing can be done, because even if government can formulate the policies, the questions raised by many previous speakers, how do we implement it? Who would enforce it? Would enforcement would be proper? And hence, I think that what government can do really in this particular case is stop the pollution. We have been talking about what in United Nations language we see. We have been not touching what is called as end of the pipe solution. We all talking about creating a pollution and then trying to find out the ways to prevent it. But we have to prevent it at the source. So we are not trying to find out who is polluting it. And when I deal with the university students, the young minds, probably all of them are younger than me, but probably they are not university students. But I'm talking about the next generation. And they ask me these questions. That we talk about filtration, we talk about energy efficiency, trying to reduce the energy of the filtration, etc., etc. But we never talk about the producer's responsibility of polluting the air in the first place. And that probably can solve many problems. That will solve the problem. Of course, the filtration companies will lose their job or the profits. But at the same time, we will be able to do the job and simplify it. Simple. That's what the governments can do. And such questions are raised by the young generation in universities, where we are now networking in order to find the solutions. Many of them say that there are nature solutions. Try to look at the nature, and they tell you that even some of the plants can solve the pollution, outdoor pollution. They are not only ability to have the thermal pollution reduced, but they also have an ability to absorb the microparticles in the air to reduce whatever we are calling about particulate matters, 2.5. So the government should do two things. Number one is go to the producers who are polluting the air. That's number one. Number two is try to find the solutions which are nature-based and promote them. And only the young generation can do it from the universities.
Thank you, Dr. Rajendra. So I think, yes, I mean, if we find the source, we can eliminate the source of pollution. That's always something even if you look at, let's say, ASHRAE standard 6.2.1, it tells you have, and this is simplifying what you're saying, but is source control is the first thing you need to look at. Then you dilute. So again, I think we need to look at the root cause. I think that's a bit of a challenge. Enrique, you've worked before with a governmental entity. You were looking into energy efficiency, and I'm sure indoor air quality was also a requirement. What do you think about that experience, and what is the role of government in implementing this?
Sure. Look, I'll start actually on the opposite side of what you talked, because I work actually at the end of this. So I help fix all of the errors that are done. And fortunately for me, there are many errors. Unfortunately for all of us, no? But at least for me, the business is good, no? Because I find errors every day. And I fully agree with you. These errors are easily avoided. We know how to do it well. For some reason, we chose not to do it well. And we keep on choosing that day after day. So I end up having to fix all of these errors, me and of course a lot of other companies in the market. Now, when you ask this relationship in the government has the responsibility to lead by example first. That's what actually I tried to do when I was in the government, is to show that these things that we say, we come to these events and we talk a lot about what could be done. But we actually need to do it, because talking about it is only the starting point, no? We need to know, of course, to be aware, but more importantly, we need to do. And we face these all the time. I mean, this is probably my biggest issue as I face, as you know, the CEO of an ESCO company, is the reluctance of the other counterparty on actually doing something. And is neither about the answers, because again, we have plenty of those. Is not about, for instance, finance, because we as an ESCO finance everything. Is not about lack of opportunity, because as we talked earlier, there are plenty of those. So my question is, why aren't we doing it? No, we did a study recently, a bunch of, CEOs of ESCOs in the market. We joined forces and we asked ourselves, how many projects are we actually doing from the available products in the market? And the numbers are horrifying. We are doing 15 out of each 100, which means 85 qualified projects that are interested in reducing their energy usage and their indoor air quality improvement are left untouched. This is not the market size. This is the people that have actively shown an interest, and yet 85 out of 100 are never implemented. So for me, that is the problem in the market, and this is where the government needs to intervene. We need to have a question of will, because tools are there, finance is there, manpower is there, know-how is there, resources are there. We just need to have the will to do it. Because one thing that this country and this region has always taught us is, if we want to do it, we will do it. No problem. No issues there. So I think we need to reach that point where we actually need to do things. And I think here in this venue is a great example that if you actually want to do it, and we have heard a lot of the other speakers talking about it, you actually find a great solution that we can be here enjoying nice indoor air quality on an energy efficient context. And it's here, no? So if it can be done here, it can be done anywhere.
Thank you. Thanks, Enrique. I agree with you on many points. Well, for different reasons, people don't go for projects, but I think these kind of we need to lead by example. So government needs to lead by example, which I think they did in some capacity. But also, I think the other issue is having successful projects and showcasing those, and making sure, because I see in some cases some projects have failed that have led to maybe some clients to say, well, we've heard about this project and they ended up in a court. And I think, we need to, showcase the projects that actually worked and get these clients more interested and at the same time more confident that these projects do actually work. Dr. Adel, from your point of view, you're working, you do a lot of research. I'm sure you're in contact with a lot of government entities that they ask you for your opinion. What do you think is, at least from your point of view, or let's say in Kuwait, how is this energy efficiency versus indoor air quality is being tackled at the moment?
Thank you so much for having me on board. Do you hear me?
Yes,
okay?
yes, we can hear you.
We at the Kuwait Institute for Scientific Research are investigating the pressing issues pertaining to indoor air quality to provide recommendation for improvement of air quality for pandemic condition and beyond. We believe that biocontamination is a key factor to consider when we really look at the indoor air quality. We in Kuwait, we have many residential buildings, and most of those buildings they use central air conditioning system, which has a ducting system, and that ducting system is made of galvanized steel. As you know, this region is, and particularly in Kuwait, we got almost 3/4 of the year we got dusty wind, dust carrying wind particle, and that dust precipitate in those ducting system. And as you know, dust particle carries so many silica, and silicon has a very high affinity for water. And if there is water, then there is bacteria and moths. And we have a lot of moths there. And because of that, we get also poor filtration condition. We have an air conditioner, but not a filter. And that air filter is made of metallic mesh, and it was easy for any particle to diffuse into the system. So we have put some.
I think we.
Sorry?
We lost you for a few seconds.
Hello?
Now it's okay.
Okay. And we believe that we need local filtration standard, possibly inspired by international filtration standard to accommodate the high dust concentration due to frequent sandstorms. And, actually, it has never been really, especially particularly for this region, on the Arabian Peninsula. The standards that has been put are really need to be modified and upgraded, and it has to be looked at it properly, because we in Kuwait we did a health study for children. Young children, their immune system is not very well developed, and because of that biocontamination and mold, we have almost 80% of the asthma, and they got it from these dust particles. So we are in Kisar is about to set a new recommendation for maintenance practice, filter replacement and selection, and the advice we have from experts. We have, I think, Dr. Iyad Attar is joining you guys, and he's one of the experts that we really collaborate together in this matter. Thank you so much.
Thank you. Thanks, Dr. Adel. Yeah, I think we do need specific research maybe for this region. And I'm sure Kisar is doing a lot of work on this. Moving to my next question. What are some of the technologies that are available? We've heard today about some, and please, anyone from the panel can take this question. What are some of the technologies currently available that sustainably and economically improve indoor air quality without heavy implications on running or capital costs? Anyone interested to take that question? Mr. Khalid, maybe?
I don't want to really intervene unless I've been introduced. Anyway, it's great to meet you, everybody. I think it's a long time that we have not met since the 2 years. I do thank the organizer for inviting us in this meeting. Seriously, there are technologies, as mentioned before, available. And there are lots of research done abroad available. One thing we have to realize, our area and our region is very harsh. It's very, very harsh. If you are really talking about design, we have to take so many factors in the design because of our harsh environment. If you are really thinking about construction, also we have to take it very seriously by heart and take it to implement such construction standards and so forth. So if we are talking about humid areas and dry areas, it has two different ways of controls and handling. To really see the technologies currently available, there are minimum cost technologies like UV lights, for example, that we can introduce and integrate, not only for new buildings, also for retrofit projects. Also, the right selection. We just heard the previous presentation that substandard filter and standard filter or certified filter, where we can spend initial money, a little bit of money, where we can save energy and we'll get a better air quality into the building. But the problem is if we are talking about the initial cost of filters and so forth, and we don't really take care of the filter type and certification, we really pay high price. Now, if we talk about, for example, the existing operation, we mentioned this to all our clients during, especially for existing building. Like Mr. Zakaria always mentioned that most of the system we have with the controls, very sophisticated controls, state-of-the-art controls. However, it's in coma. It's not even in the control itself status. It's all in, overrides and so forth. These technologies, it's already there. We know it's already there. The problem is, do we have the end user awareness? We as designers, we do sit with them and we do give a training and we do. However, once it goes all the way to the maintenance and operation team who are really doing the work, they are not even there. So we are really focusing in the owners and the end users, but we don't really focus on the operation team who are really live with these products. I mean, the awareness program, I know actually we are doing lots of programs for our high technical qualified members. However, if we really go and take the real value of operation, it's with the technicians, where we need to train and bring the awareness to them.
Thank you, Mr. Khalid. This brings us to another point here, the existing building. So, as you mentioned, okay, we've heard about technologies, energy recovery, bringing in filters that do provide the same filtration at a lower fan cost. But remember, always with let's say outside air, we have the cost of fans, which in our region is not the highest. The cooling normally is the biggest component. Fans also are very important. But for existing buildings, Mr. Khalid was mentioning, we have an issue. We might have the best design, best installation. If it's not run properly, it won't give us what it was done to do. Enrique, back to you, because I know you do provide such solutions. How can we finance retrofitting existing buildings to improve both the IEQ and their energy efficiency? Taking into consideration that you might go into a building where the indoor air quality is not that good, and you still want to improve the energy efficiency, and you have to also, again, balance and tell the client, no, I need now to change your baseline to take into account that we fixed the IEQ. Tell us about that part of the business and if any success stories that you have.
Sure. I think That is actually a very good point, and I would like to also address this topic of the operations because I think it's also quite important. So the work that we do when we enter into, an existing building with the purpose of retrofitting it is with the purpose of improving the conditions that we encounter there. And this improvement is not limited to the energy side. It's inclusive of the comfort, of the functionality, of the purpose, and of course, of the occupants, no? We do a lot of retrofitting, for instance, in schools and in hospitals. And we find very curious things. I can give you one example without, of course, giving any names, of an hospital we recently audited that had the fresh handling units off. And we were a little bit surprised by this and said, okay, how can you have your fresh handling units off in an hospital, no? And the purpose was to save energy. I said, but you see, now we are missing the point, I think, no? Saving energy is not sacrificing other parts of this equation, no? We need to bring this equation to a point where we actually finance a project and take, for instance, our case, we actually deploy our own capital on these retrofits. So, which means if they don't work, we both don't get paid and lost our capital that went in. So it's a kind of a double loss for us. But we need to do it with the purpose of making these buildings work much better to the standards, like ASHRAE, and to the comfort of the occupants. And in our previous experience, what practice teaches us is that this is actually possible to do. We can actually finance a project to vastly improve indoor air quality, by increasing the energy efficiency. And this is not conflictory. So we can actually do it quite effectively, and we have done it repeatedly in the past. We have to leave a building better than what we found it, because otherwise our job is not done. Now, just to finalize on this operations part, I think there you touched a very sensitive topic, which is most of these buildings actually have a lot of great tools. They are just not used, or not used the way that they should be. For an ESCO, we can only get paid if we achieve the savings. So it's not that we put good enough tools there. If the end outcome is not achieved, we are not paid, no? So for us, operations have a very crucial impact on this, and we take over operations of most of the assets that we actually retrofit for that purpose. Now, with this also comes a responsibility of doing a proper handover, because again, we will be there for a certain contract time, 5 years, say. But those assets will be there continuously for the next 10, 15 or more years. So it's our responsibility also to do a proper handover to the operational teams there so that they can use it effectively after we leave. And I think that point is very important. Sometimes it's not about the tools, it's about how you use it.
Thank you. Thanks, Enrique. Yeah, I think that's a fair point. We need to educate the clients and show them, like, why is it important, why IEQ is important, and for the future as well. Because every building you retrofit, the client does get also that education, and probably they will be running their building after you leave in a certain way, which is better. Dr. Rajendra, I know you wanted to add a point. Please go ahead.
No, every time we face the adversity problem, we talk about creating awareness. That is a pretty long time process. You create awareness, then you create a finance, then you try to change it, and then we don't know whether that change works or not. I think it's a question of really finding out how to finance the retrofitting has an answer. Who created the problem in the first place? The point is the question of retrofitting comes mainly because the buildings were built at that time to take care of the air pollution at that time. So try to find out who was responsible for that air pollution. It's an internationally accepted principle in all conference of parties and meeting of the parties, that polluter has to pay. So if at all transport industry has polluted the air, or steel industry has done it, or aluminum industry has done it, then you should be asking them to create a fund for retrofitting the existing buildings. See, tinkering with the energy efficiency and financing energy efficiency for filtration or better filtration is not going to solve the problem. Problem will get solved when a polluter pays, the government manages that fund, and then starts retrofitting it with the help of the private sector or the public sector. This is what needs to be done. And for the new buildings, of course, the things are getting better. I mean, we have people like CPI Industry who has created awareness. It's a 6th forum, World Forum. So they started working on IEQ much before the COVID-19. And today we are sitting in this hall. It's an excellent ventilation. We don't have any problem on that. Personally, I find that after the lunch, I look for sofa, even in these conferences. This time, I didn't look for the sofa.
You didn't have carbs, maybe.
And it was such an enjoyable thing. And today, of course, some of the people have left, but I saw the much larger number of people, audience. They were there here about 1 hour back. And they were enjoying the things. So I think
agree
we should look at the out-of-box solutions for taxing who created the problems.
That is a good point that will raise a lot of points as well. But yeah, this could be a solution in some cases. Like, let's say if you have like industrial facility that is polluting a building next to it, that, yes, I would agree on that point. But let's say in a building, it's an office building, the pollutants are actually the people producing CO2 and other contaminants, VOCs, then it becomes much more difficult to point fingers. And I can point a lot of fingers on designers, on operators, on it becomes a little bit difficult from that end. But yeah, I agree that that could be something to be looked at certain points. We still have only 5 minutes. I will open the floor for questions. So if anyone has any question, please introduce yourself. And if you have a specific question to any of our panelists, specify their names if you remember them. I do not see any hands. I might be turning blind. Okay, I see one. So we have a question that side. And we have... Okay.
Hassan, if you can also ask a question about using renewable energy.
Yeah, that's a point that we've missed. So how do we bring that into action? So if we have abundant energy, I think these problems will not exist. Saying like, well, let's put 100% fresh air if the energy is for free. So whoever wants to take that question, how do we bring the renewable energy into the mix?
I will talk about it a little bit. Having renewable energy is important and is fundamental. However, we should always remember that renewable energy does have a carbon footprint. So it is not a clean energy as such. When we do renewable energy, when we have a wind farm, we need batteries for the wind farm. We need to manufacture batteries.
So there's embodied carbon.
So there is a carbon footprint. And for example, one of the studies that I have read where they calculated the carbon footprint of a wind farm, and it happened to be 1/3 the carbon footprint of a coal-powered plant. So we should take this into consideration, and keeping in mind that having this 1/3 is a great achievement toward a clean environment, and it will help us really in having better indoor air quality only for those who would like to still make a balance or find a meeting point between energy consumption and the indoor environmental quality. So this is what I think that
Thank you. Anyone else want to tackle this point?
Yeah, I would like...
Yeah.
Can you hear me?
Yeah. No.
I would like to add to that. So first of all, I think I still see that we are talking about indoor air quality and say like, okay, if if we have renewables, then we can have a better indoor air quality. I think these topics are not related at all. We need to keep on trying to improve our energy efficiencies, regardless of renewables or not. We have to improve our indoor air quality regardless of what it takes or not. And again, it does not mean that having a good indoor air quality means you have a huge energy bill. You have to use the tools which are available in a proper way. As you say, the operations. We have to qualify the people for it. Period.
Thank you. Yeah, we'll take one or two questions. Do we still have time? I think we have like 1 minute maybe left. So yeah, we can start here, and then Basil, you can ask a question.
Yeah, I am Tahnia, the refrigeration engineer for Spinach Supermarkets. My question is that the building owners in Middle East, they are not the people who are living in the buildings. The 99% are the tenants. And the investment for the filtration improvement goes to the builder who is least interested to doing so. So there should be a regulation to implement these practices. And number two is there should be a display at the entrance of the building that what is the indoor air quality, what is the status, the practical values. These are the values, this is green, this is yellow, or this is red. So when I'm entering a building, I should know what is the condition of the air quality.
Yeah, I think that's a good point. I think it was mentioned before in the other panels. Dashboards could be good, especially in, let's say, public buildings. If you go into a mall, seeing a dashboard showing the CO2 levels, VOC levels is something. Actually, I've discussed this with MAF during one of the conferences, and they were planning to add this, let's say, in their malls. Thank you. Very, very good points. We'll take one last question. Basil, in the back, please.
Yeah, my name is Basil Ambari. I'm the managing partner of Intercool Central Air Conditioning. Thank you for the panelists. Thank you for CPI for putting together such a great forum with the very important topics. I think the discussions that has been going on, it's great. Everybody is enthusiastic about doing the right job. I think we have the tools and we have the means to do it. However, I think we need to have a government emphasis on this because building owners really don't take indoor air quality seriously. Indoor air quality for building owners, whether it's a supermarket, whether it's a mall, whether it's except in healthcare facilities, you really don't find the importance of indoor air quality with building owners. So if the government does not really emphasize and draw regulations and emphasize on these regulations, I don't think we are going to move forward so much. We will be here next year. We will be talking about the same thing again.
That's the good part of it, that we'll reconvene. But yeah, yes. The bad part is that we're going to be facing the same issues.
Yeah, so we need the solutions and somebody to take the bull by the horn and run with it and say, this is what we need to do. The building owners has to take it seriously and implement an indoor air quality procedure.
Thank you, Bas. I think, yeah, that's a fair point. I think regulations are there. Let's say if you look at SAFAT, for example, or Dubai Green Building Regulations now turned into SAFAT, and the Dubai Code that was recently launched, since a long time we have the requirements, but enforcement is the tricky part. And how to enforce and how to make it feasible to enforce is the $1 million question. Thank you to our panelists. Thank you very much for joining us. Thanks for the audience. I'm sorry we're out of time. I know a lot of people getting hungry now and waiting for dinner. We still have one more presentation, so please help me give a round of applause to our panelists.
I would like to have...
Thank you. So now we are moving into our last technical discussion or presentation. This presentation is about ZAG IoT, Connected Solutions for IEQ Monitoring. Actually, I did use ZAG on a couple of projects and found it very interesting with all the data. I'm sure we're going to hear more about that now. It's going to be delivered by Yasmin Skanji, who is the Scientific Director of ZAG, RDI Department, and of Engineer Group, which is a world leader in services and solutions related to IEQ. Yasmin holds a chemistry PhD from Polytechnique School Paris 11. She joined Engineer in 2017 to head up the innovation department within the group. Please help me welcome her back to the stage.
Thank you. So I'm very honored and happy to present you the last presentation of the day. Hope you're not that tired with all this interesting talking. So let me introduce you quickly the group, Engineer Group. It's a French company from 2003, leader in air quality services and mainly having a strong relationship with our customers, as we are implemented through 30 agencies in France, actually, and also 14 all around Europe and Dubai to be the nearest to our customers and being able to apply our services very fast. Our expertise is within 3 business axes. Mainly, I will talk about air quality services today, as it's the main subject, structured around different business sectors. And main of our services are audit control constancy, clean rooms cleaning, air duct cleaning, sealing duct aerodynamic, and also the last part that I will focus on will be monitoring treatment of indoor air quality with IoTs. So ZAG department was created in 2017, 5 years ago, to provide this complementary service to the group with the continuous monitoring. A quick talk about air quality in general, but we talked a lot about the health and what we have about these invisible pollutions. And the main objective of the IoTs will be to provide you a direct visibility of the environment that you are breathing. So what we can find naturally would be the allergens and bacteria and viruses, of course, and also chemical in the air through industrial pollutants, chemical products, odors, and also particulate matters that are surrounding us. You probably heard about this study that told us that air quality is responsible of 8 million of deaths per year. It actually kills more than COVID-19. And mainly, if we are focusing about indoor pollutions, 4.2 million deaths per year are concerned by indoor pollutions and not outdoor pollutions. Main of that, 73% of that are directly related to PM10 and PM2.5. And what our new habits and our new lifestyles is creating actually a new kind of pollutions. If you are focusing on the histogram that you have there, we have actually a new nature of pollutants specific to indoor air, based on our new habits, our new smart buildings, the furniture that we are using, the products, the sanitizers that we are using actually during the pandemic. And it's not at all related to outdoor pollutants. Of course, it has a direct impact on health, and we have discussed about it all the day, so I'll pass it very, very quick. And the particulate matters are super small. This is why we are focusing more and more about ultrafine particles and see how we can improve low-cost microsensors to be very efficient about measuring ultrafine particles. As the finest they are, the deepest they will be able to get into our bodies. WHO has reviewed the thresholds in 2021 after COVID pandemic to lower concentration values because of the chronic exposure problem to indoor to air quality problems. And we have also lots of recommendations, for example, the label well for smart buildings that encourage maintenance sections to put some monitoring solutions to measure at least these kind of parameters that are cited here, like PM10, PM2.5 carbon dioxide, carbon monoxide, ozone, nitrogen dioxide, VOCs, formaldehyde. And also they are totally encouraging to have real-time displaying of the data to inform the customers about air quality in general. So this should be not only a recommendation nowadays, it should be more and more after the pandemic that we have been through, more mandatory, more and more, I think, in the future. To present you how we worked about IoTs, we've did actually the same stuff that Dr. Stephanie presented earlier in the morning. We have developed this station focusing on 11 essential parameters that we need to measure in the tertiary areas to get real-time real-time data analyzing. Directly connected, you have a single measurement every 30 seconds, and you have like real-time data through mobile application and web application to get a direct visibility on the pollution that you are directly breathing. Plus, we're providing also the open data of the outdoor index to let you correlate like outdoor pollution to indoor pollutions to be able to see if it may have an impact or not. Actually, in France, we are totally confronted on existing buildings, old buildings. So we need to follow the steps that is first putting a diagnostic, measuring, then the analyzing, informing the people what we can do, and find a solution about them impacting some maintenance, a specific maintenance. Here in Dubai is actually a little bit different. We are like in a kind of city of smart buildings, and we have a high impact of outdoor pollutions also because of the desert and the climate. So, plus, we cannot focus only about the outdoor reference station that you have as it's regional. And in a city like Dubai, the volume of the buildings may have an impact also on the outdoor. So it would be great to have also an external and outdoor point of measurement to correlate the outdoor air pollution to the indoor if we need to monitor and pilot the BMS system, for example. Just to have a look about the application and how we can get the data very easily through our mobile app and get some alerts and recommendations depending on the thresholds, WHO threshold or specific thresholds if you are concerned on industrial applications. Some use cases where we've provided like many solutions, for example, in offices, open space offices where we have only HVAC system, not ventilation, only cooling systems in France. So we are able to provide some purifier, additionally to add some circulating air and filtration to provide like a better environment for our customers. Also, we have many laws came on in France actually since 2018 concerning all the nurseries and the schools and high schools that make them mandatory to measure indoor air quality parameters in these kind of areas. And in 2023, it will be mandatory in all the establishments receiving publics. Here, for example, we are directly measuring the air quality in the BMS concerning actually the impact of the air galleries in the Fondation Louis Vuitton. They were mainly concerned about preventing mold developments for protecting arts and also the visitors. Malls and public buildings, for example, here. Also having some outdoor applications about using this kind of monitoring and low-cost microsensors to be able to provide, for example, it's the construction of the project Grand Paris in Paris, the new subway lines, and they need to measure continuously the indoor air quality on the work area. It's mandatory to see if the working area has an impact on the residents' behavior surrounding it. Many examples also in the industry, we are able to totally adapt the configuration of the station if needed. We can use electrochemical specific microsensor to measure specific industrial pollutants like H2S or some hydrocarbons, or depending on the demands. And we are considering that air quality is not, so it's super essential for us to measure the air quality in the area that is mainly occupied by our clients, where it's in the area where we live, where we're spending most of our time, but also measuring and maintaining the ducts also is necessary, as a good air quality comes also from a good maintained duct which brings the air that you are breathing into the buildings. So we have provided this solution named ZAC Dust, which comes, it's directly plugged on the open doors, and it will measure continuously the thickness of dust directly in the duct. Why cleaning your HVAC system is necessary? For energy saving, health, comfort, and well-being of the occupants, of course, reduction of maintenance costs. We will encourage you to predictive maintenance that will make you have makes economy, and also security and risk preventions. Actually, in Europe, we have a specific standards that we are, which is the EN 15780 for clean ventilation systems. It's determined through, depending on the typology of the building, the activity, with 3 kind of levels. And it will make you, it provides actually only thresholds to prevent and make the maintenance operations. For example, if we are like in a medium level concerning like offices, hotels, restaurants, buildings, we will have like for supply duct networks a specific threshold to respect. For return duct networks, another one, and for extraction, the highest level would be 9 grams per meter square. And if we are above these limits, we definitely need to get a cleaning. So it works that it's totally connected through a LoRaWAN network, and you get all the data providing on applications. You can also make it totally automatic to your BMS system. Like that, it will you'll get the alerts at the same time. Talking about maintenance costs, actually many of our customers are working based on corrective maintenance. We have actually 3 kinds of maintenance, if we can say that. The corrective one, the preventive one by contract, and also the predictive maintenance. Today, IoTs may be an invest But this low-cost microsensor will, on the long term, will provide you lots of economies, up to 30 to 40% of economy if you pass through predictive maintenance, replacing corrective maintenance by predictive maintenance. So definitely we need to consider this new kind of, these future technologies to provide you the information that you need. Some examples here, mainly installed in lots of systems, so we can adapt it to many models of open doors, flat or curved, and different sizes. We also have developed a specific particle counter for cleanroom application and controlled environments, where we will be able to measure ultrafine particles like 0.3, 0.5, 1, 2.5, and 5, and provide direct data, indoor data to control ventilations, and also get ready for qualification and certification. It's totally complementary service, and it's not actually replacing the mandatory audits, but it will provide you like a direct alerts if needed. And actually, last month we were so proud to get the ISO certification 21501-4. That is totally concerned by this kind of particle counters for clean rooms applications. So here, for example, we are installed in a pharmaceutical production site, ISO 7 classified clean rooms. And also we have so many demands during the COVID period for dental clinics and ORL medicines cabinets, as they are working a lot with polluted aerosol environments. Our next product that which will be commercialized for us in September this year is a lighter version of the first product that I've presented you, that will provide you like a direct information through a direct screen on it, or directly communicated through the application as the others. We'll be able to at least monitor the essential parameters that we are talking about the whole day long, like the temperature, humidity, the CO2, the VOCs, and also the PM1, PM2.5, and PM10. Actually, my main objective with the ZAC is working on the calibration and providing the best accuracy, making our low-cost microsensor more efficient and more specific to provide you the best data. And we're not only providing intelligent solution and IoTs, we're providing an entire service with it, as we are a team of engineers and experts, and this kind of technology also necessitates lots of maintenance and also yearly calibration depending on the technology that we are using. So you're not alone, like we're totally following our customers, counseling, giving recommendations, alerting if needed, and giving like a full diagnostic if needed. Working also with the right manufacturers and the maintenance teams in a building to get back to the source of the problem more easily with the continuous monitoring compared to the punctual audits. That was very brief, just to present you a little bit our technology, but if you have some question, I will be happy to answer it.
Thank you. Thank you, Esme. I don't think unfortunately, we don't have any time for questions because we still have one final presentation, but anyone wants to ask Esme any questions, she'll be here. So now we're going to move into the last technical presentation, how to utilize the power of air curtains to ensure a better indoor air quality while saving valuable energy. This presentation is by Jan Svalenson. Sorry if I butchered the name. He is the Business Development Director, Frico AB, Sweden. Please help me welcome him to the stage. Do you have your mic?
Oh, I think I'll use this one instead. Thank you very much. It's a pleasure to be here among so many distinguished speakers before me. And we have talked a lot about indoor air quality. I heard before that it shouldn't be any more presentations, so I'm sorry, but I will try to be so concrete and precise, because I know that something good is waiting outside as well. So bear with me a couple of minutes. Indoor air quality. I will attack it from a different angle. So while saving, I will come to that, because we heard during the presentation, that's been very good now, that we have talked about indoor air quality and how can we get some money from that, and how can we retrofit? So I think I maybe have some answers to that. So these are the points I will go through. Maybe you're surprised that we're going to talk about the cold rooms, etc., but we also need a good indoor quality, indoor air quality in the cold rooms. You will see that later. I'm going to give you some case studies as well. And also we're going to see how we can make money on using our units in this sector. Importance of cold chain and cold rooms. I think we are in the right area here now, because this is the sustainability area. And I guess many of you have heard of Agenda 2030, that the United Nations created a while ago. And there is one specific goal that is very interesting for us when we talk about supply chain and the cold chain, and that is target 12. And actually, there is one paragraph, 12.3, that is interesting for us, because I don't know if you know, but we have a big problem today with food waste. Actually, 1/3 of all food that we produce are wasted. We throw it away or it gets destroyed. So one of the goals in Agenda 2030 is to halve this food waste until 2030. So we have a couple of years left to work on that. So, by the way, when we eat out there, remember to eat everything on the plate. So no food waste, please. So, and they target on the supply chain. And supply chain for us is the cold chain. Cold chain means the way from the farmer all the way to the consumer. So there are different steps that the food eventually has to pass until it reaches the consumer. And it has to be protected very well during the whole way. So why focus on the cold chain? Well, as I said before, 1/3 of all the food is wasted. That's enormous. So let's say, and of course, all that food wasted, we need a lot of energy to produce that. And if we turn that, let's say, all that energy and see what kind of carbon footprint that would give, actually, food would be the 3rd biggest, let's say, player when it comes to making its carbon footprint. So it's a huge target, it's a huge challenge for us to protect the cold chain. And of course, cold chain, that's interesting to us because we, as Frico, representing Frico, working with air curtains worldwide, and actually world leader in Frico in air curtains, then of course we are recommending air curtains in the different steps. There are some basic, let's say, rules about air curtains. What happens is, of course, if you don't protect the door, then you get the warm air from the street coming into the premises, cold, expensive air goes out. We were talking about retrofit before, during the panel. And I mean, here is a way to retrofit these premises by using the air curtains in a very simple way. And it's not cold air that we are losing, conditioning air that goes out in the street. We can also receive a lot of smoke or contaminated air from the street if we don't protect the air, protect the door. So here's an easy way to retrofit the premises. So what happens when we have a door that is not protected? We have the shop on the left side. Warm air is lighter and it streams into the shop and we are losing all the cold air. This is all basic for many of you, of course. But anyhow, we also using thermo camera to show. Now we put on the air curtain and bit by bit it pushes back the cold air into the shop. No, sorry. Sorry. The cold air is going out from the shop because we have no air curtain here. Same thing here. We can show that the smoke is going in on the top that symbolize warm air, but when you go down, the cold air is pushing out the smoke because the door is unprotected. So those are the rules behind the air curtain, so to say. So what are people using today instead? And if we go back to cold storage, they are using PVC strips. PVC strips, easy to install, not so expensive, but after a while they get ruined. And you work with forklift trucks in logistics centers and they easily go through very quickly and they hit these PVC strips. And you have cold and warm air meeting, so you have condensation and you have low temperatures, so the ice is sticking on this. From the beginning, very transparent PVC strips, but after a while you don't see what's on the other side. So actually we have a lot of accidents going on in the logistics centers when the forklift trucks pass very quickly. So we have a problem with condensation. And condensation, well, we talked about that before as well. If you have a lot of condensation, it builds up. And in this case, it's building up ice. And here are some bad examples if you don't have a proper protection on a specific door. So, solution, well, for me, easy. You put the air curtain, and you should use an air curtain that is covering the whole door, the complete door, to get what we say an invisible door. And going back to the graphics that we had before, it's not 100% protection, but still up to 80-90% it can prevent the cold air leaking out from the shop or from the cold store. Here, now we start to work with the air curtain, and you can see bit by bit how it's pushing back the cold air back into the left side, which is the shop or the cold store. Same thing with the smoke, not even in the top, it's center. So, yes, it's preventing the smoke to getting in. Air curtains in cold room. The problem is that we have this ice building up, and the ice building up means that we have a lot of extra eyes on the cooling equipment, so you need to do a lot of defrosting as well. But with the air curtain, you have a good, much cleaner environment, and you have a better, let's say, visibility on the other side. And now an example, we have an air curtain running, but now we turn it off on the left pictures and look around the lamp. You see what's happening. All the condensation builds up, and bit by bit you have ice building up. We do the same thing on the other side. We open up, but we are leaving the air curtain running. And you see a clear difference. Maybe you see, I said before, it's not 100% protection. Maybe you see some condensation, but it's a huge difference anyhow. And of course, by having a more even temperature in the cold room, we have less impact on the cooling equipment as well. The cooling equipment is working more smooth. The load is less all the time. So, optimal solution, you put an air curtain for the cool room, but not only for the cool room, but also for any supermarket or any shop where it's needed. Summarizing some benefits, yes, I talked about the visibility, less accidents, reduced ice buildup, frost and condensation. We have energy saving. I will show. I'm not only telling that, but I'm going to show you a few case studies where we really show how we can save the kilowatt and improve safety and hygiene and less maintenance. And of course, as I said from the beginning, we are protecting the cold chain. We are saving food. Case studies. We've done a couple, or quite a lot, because yes, I say that we save energy, but what we are really measuring, not only in cold storage, but also supermarkets, the difference with and without the cold storage. Now, this picture was a little bit distorted, but anyhow, I can tell you, this is a 20 square meter deep freeze storage with a negative temperature of 23 degrees. This is made in Thailand, and it's 30 degrees plus outside, so it's a big delta T. But anyhow, we were measuring the energy consumption, and during this month, and they were using PVC strips, we had the consumption of these 2,754. Taking them away, well, now it's even more distorted, but I can tell you, we managed to reduce the consumption with 25%. So taking away the plastic strips, putting up the air curtain, we were reducing the consumption. Well, you can see from 2,700 down to 2,280. Another picture. Here we have 6 cold rooms. And with this consumption, we did the same thing, took away the PVC strips, installed the air curtain, and then we also managed, I think we even came down to 27% in lower consumption. So, and I mean, kilowatt, electricity is getting more and more expensive. So it's really worth, and we talked before about total life cost of the units. Air curtains more expensive than PVC strips, etc., of course, but in the long run, it pays off. We did the same thing with a convenience store, a supermarket, and they had this consumption for a month for this unit. And we installed the air curtain, and we managed to go from 3,300 down to 2,400 kilowatts. So money talks again. Kilowatts is expensive, and it's going to be even more expensive, I'm afraid. You know what's going on all around in the world. So less consumption, less condensation, less maintenance, and better visibilities, and less accidents. We are using other ways to measure how it works. We use CFD analysis, computational fluid dynamics. And actually, what we did, this is a store here in Dubai, and the red spot or the violet spot in the middle, that's the air curtain, and inside is the shop. So what we did, we measured how it works with or without the air curtain running. And actually, we are at 40 now, but during the summer we will get up to 46 degrees. So, and inside, yes, they wanted 22 degrees. So they had this when the door was closed. So what we did instead, when we turned off, we opened the door and turned and didn't have the air curtain running. You could see with the help of the CFD analysis what happened in the store. The average temperature raised from 22 to 28. And this is a nice tool. I mean, here you can see once again, not in reality really, but how the CFD analysis can show how it works when the air curtain is not working. Here is the same thing, and we have the air curtain on, and it works more or less like a door. And here we see the, let's say, the airflow going over the door, protecting the door and keeping the warm air outside. So this was Frico's angle to indoor air quality, and but I think it's necessary. It's nice to talk about all the on an academic level how the importance of a good indoor air quality, but it's also very important to link it to concrete practical cases and see how it really pays off. I mean, otherwise it's very easy for a shop owner to buy a cheaper unit or keep on with these plastic strips, etc., if we can tell him that actually you should change, you should pay a little extra, and then you will save in the long run money. So I remember I got the question, what is my favorite building regulation? I think it was from a panel discussion here before. And I think these Sustainable Development Goals, especially 12.3, that's a good one. And I keep for that one. Maybe the time running out. But anyhow, when you have time coming back, take a look at our installations here, because we have down in the coffee shop and and also at the main entrance and at the side entrance, we have our air curtains installed, together with a nice ventilation system from System Air as well. So I try to wrap it up quickly. So, okay. Thank you very much. Thank you very much for listening.
Thank you, Jan. That was a very good presentation. I've always advocated for air curtains. I think it's just as simple as closing a door. Yeah. It's an invisible one, and we all know and think that air curtains should be used. I think one of the things that maybe need to be addressed are standards to test and verify air curtains. I think this is something maybe the industry needs to work at as well. Thank you very much. Please help me give a round of applause to Jan.
Okay.
Thank you.
Thank you, guys.
All right, this marks the end of the technical presentations. I'll give my closing remarks because before we go to the sponsor recognition and a vote of thanks to our sponsors that I'll thank now, and again we'll have this token of appreciation for them. Today was really an amazing turnout. Thank you for everyone that was here. Thanks for the panelists from all around the world. I would say it is indeed a world IEQ. We've learned a lot of things. I've learned a lot of things personally. So we've talked about benefits of indoor air quality, how to improve indoor air quality. We had doctors that gave their opinion on that. We had system integrators government entities, associations like Eurovent and others, Abu Dhabi QCC. So we've kind of heard from all perspectives, and I think everyone, learned something today. What are the main takeaways, for me at least, is that IEQ, after the pandemic, became something that we cannot play with anymore. It has to be something that is a priority. It's not a second thing we look at. It has to be a priority from this design up to the operation of buildings. And that's something that we collectively need to think about and need to apply and need to educate others as well, because that's our health. That's the health of us, our children, and it's of a premium importance. So thank you everyone for joining today, and hopefully we'll see you in the next year edition of the World IEQ. And now I'll leave it to Mr. Frederic to thank our sponsors. Thank you very much.
Well, thank you very much, Hassan, and a very good evening to you, Your Excellency, ladies and gentlemen, distinguished guests. It is my utmost pleasure indeed to see you all, welcome you all from all over the world, indeed today to the 6th edition of the World IEQ Forum, and I hope it was a fruitful day for all of you, and a good evening as well to our online audience. Some of you ask me what a hybrid event means. Hybrids in our awful jargon means that it's both on-site, physical, and online. So we have also an online audience, as the event is being broadcast on the Swedish pavilion for the Expo website as well. First and foremost now, I would like to thank our co-host, Systemair, for making our dream come true. Whenever we've been searching for a venue to host this event, I cannot tell you how much of a struggle it has been to find one without a moldy carpet or devoid of any VOC-laden air fresheners or other smells. And today, for the first time ever, as you could all experience for yourselves, the best indoor air quality in the country for sure, which only the top of the Mont Blanc in France could probably beat. And by the way, here's an invitation to our French sponsors to make that happen for next year. Why not? We are also extremely honored and grateful for the presence of the UAE Ministry of Climate Change and Environment. They have been listening to the discussions today, and I'm sure, hopefully, something will come out of this. We heard quite a few times today, though, the term fresh air being used. And looking at this picture, a picture like this, we are also thinking to enlarge the scope of this conference to include outdoor air quality as well in future editions and its obvious impact on the indoor air quality. By the way, this is a photo of a filter capturing fresh air outside an office in a green area in the UK. So maybe we also ought to rename the concept of fresh air. Here's food for thought. Now, probably the only silver lining of this horrible COVID-19 pandemic the world went through was the awareness increase it has generated in terms of indoor air quality and ventilation standards. And for the first time in my life, as I traveled to the AHR Expo and conference in January to Las Vegas, I witnessed something amazing. I found not one, but 2 air purifiers in my hotel room, which were not even pre-requested. So it seems we are finally getting somewhere. And we need to be grateful for that and hope that more and more hotels will globally follow suit. Over the last few months, though, we have heard this particular sentence over and over. We have to learn to live with COVID-19. According to Professor Gilbert Deray in France, it does not mean much. Living with a virus is indeed a very strange, if not dangerous concept. We have to fight a virus and bring it to an acceptable level. And as of today, still nothing, and these are his words, can predict whether we will ever reach that acceptable level. That is why we have to keep fighting. And along with the available therapies, vaccines, and so on, we will hopefully one day reach that safe, acceptable level. But saying on its own live with COVID-19 is equivalent to say, keep drinking non-potable water, which doesn't make sense. When we discovered years ago that water was a carrier of cholera, we made water potable. So now we know for a fact that COVID-19 is obviously airborne. The solution is to make the air, our air, breathable and safe. And that should be the focus of our fight indeed, not simply live with COVID-19. That is why we feel very proud today to be surrounded by companies and experts whose job on a daily basis is exactly this: make our air better and safer. And I would like to use this platform to thank them indeed for their effort and participation. And they may join me on stage and remain on it until a group photograph is taken. So please give a warm applause to our co-host, Systemair and Frico. Thank you very much for your support.
Thank you.
Thank you very much. Our bronze sponsors, Camfil. Please, Frico, of course. Jan. Pleasure. Thank you very much. GPS and Intercool. Can we have some background music, if possible? That would be nice. There we go. The snap of a finger is amazing. Iginer and Zach. Our associate sponsors, AMCA and Condare, they are still among us. And moving on to our strategic knowledge partners, AHRI, Eurovent Middle East, DC Pro Engineering, GRFN, Guth de Gonzo, Protect Cooling, Suemi Design, SCCN, TER Policy Center, and our strategic HVACR recruitment partner, carisbay.com. Please join us. Some more people are joining. Thank you all for your amazing support. Thank you very much. See you next year, hopefully. And now please allow me to quickly run through our latest offerings and upcoming calendar of events. If you have not already done so, I would like to direct all suppliers and manufacturers to register for free up to 15 product categories on our website, climatecontroldirectory.com. And where you can see that we already have 97 companies listed under the indoor air quality sector and many more under subcategories. The 2023 printed edition will be published during the Big Five Show Week in Dubai on the 5th of December. Our next event, the 5th edition of the Client Consultant Contractor Conference, will take place in Dubai on the 16th of May, and the theme will be business growth and financial stability in the midst of a protracted pandemic. On the 30th of May, we are looking to host a very heated debate indeed as part of our Chilled Water Systems versus VRF conference in Dubai. And on the 16th of June, we shall be launching a new conference concept called TCO, or Total Cost of Ownership, focused on energy efficiency and retrofitting solutions. On the 24th of September, we shall be hosting our Food Chain Conference in its 11th edition, which will travel to Doha, Qatar, looking at the preparations for the FIFA World Cup in November. On the 24th of September, our Daisy Dialogue on district cooling in its 8th edition will travel to Cairo, Egypt for the first time, followed by the 9th edition in Dubai on the 25th of October. And at last but not least, the Oscars of the HVAC industry, the Climate Control Awards, most probably in the brand new format, so keep tuned, will conclude the year on the 5th of December in Dubai, sponsored so far by Al Hadara Consulting and Sil Abeg. I would like to give a heartwarming thanks to our moderator as well for a great job. And Surrender and I would like to thank wholeheartedly the World IEQ Forum Organizing Committee as well for working tirelessly towards a successful event. Annika Alstrand, Chris Lopez, Dovin Pani, Hannah Joui, Kirsten Vride, Namrata Suratswani, Nerissa Deoraj, Merciana Lopez, Morten Schmelzer, Ranjana Konat, and the lovely team at the Sweden Pavilion. Well done. Please enjoy the rest of the evening. Thank you and bonsoir. Masalama, smaklig maltid, and bon appetit. Please join us for dinner, which will take place on this floor, as well on the rooftop, if the weather allows it. Enjoy. Thank you very much.